สวัสดีค่ะ Good afternoon, ladies and gentlemen, and welcome to Sustainability Spark by PTT Group 2026, Sparking the Future. I'm Nun Nachanan Lengarunwong, your MC for this afternoon. And of course, this morning we've learned quite a lot. We heard a keynote on Thailand's sustainable future and global perspective on net zero and innovations, and followed by a UK case study on turning net zero into economic growth, along with strategic insights from global experts on Asia's directions after COP30. So this afternoon, ladies and gentlemen, at SparkX Stage Innovations that moves us forward, we will explore future innovations and technologies that are transforming sustainability into, of course, a true engine for economic and social progress. So for our first session, we invite you to step into the clean technology revolution, from technology to traction. We'll be unveiling how cutting-edge and also advanced technologies from industry leaders that are transforming futuristic visions to real, capable, and also commercial value. Of course, you've heard about CCS, the carbon capture and storage, also the small modular reactors or SMRs, and ammonia co-firing. So these innovations, ladies and gentlemen, are not only accelerating sustainability, but also delivering tangible economic and social impact. So we are going to have the individual sharing session, and then will be followed by a panel discussion. So through this session, we will explore 3 key technologies that play an important role in reducing carbon emission while ensuring energy security. Namely, as I mentioned earlier, the first part, which is carbon capture and storage, or CCS, a technology designed to manage and reduce carbon emissions from large-scale industrial sectors. And this session will be conducted by Mr. Jonathan Pierce, who is here with us from CO2 storage team leader, British Geological Survey. And after that, we will have another very interesting thing that's happening right here, the small modular reactors, or SMR, a new generation of nuclear energy, and also to be safer, more flexible, and better suited for the energy system. And this we are honored to have here with us Mr. Rasmus Bjergård, Chief Business Officer for Saltforce Energy. And last but not least, we will be hearing on ammonia co-firing, an alternative fuel approach aiming to, of course, reducing carbon emission, from Mr. Tadashi Sumida, who is here with us, the Group Manager, Mitsubishi Heavy Industry. So at this time, ladies and gentlemen, we are going to start off from the individual sharing session by our distinguished keynote speakers. So please join me in welcoming our first speaker on the stage, Mr. Jonathan Pierce, CO2 Storage Team Leader, British Geological Survey, on the stage. Please welcome.
Good afternoon, everybody. Yes, thank you for that introduction. My name is Jonathan Pierce. I'm the head of the CO2 storage group at the British Geological Survey. My key message to you all this afternoon is that carbon capture and storage, particularly the storage aspects, which is what I'm going to be focusing on today, really require that publicly available knowledge of storage feasibility. You can't really decide how much CCS you want to deploy if you don't know how much CO2 storage capacity there is in your regions and in your country. That's really important for a number of reasons, as I'll come on to, but particularly around building confidence amongst industry and policymakers, and of course amongst the public. And it's really understanding that capacity and the safety around the containment risks that I want to try and emphasize this afternoon. A little bit about BGS. We are a world-leading geological survey. We are a public sector organisation. We're the UK's National Geological Survey. We've been in existence for 190 years, in fact, so a very long time, and we were first created to look for coal resources to support the Industrial Revolution in the UK, and now we're looking for ways to put that carbon back in the ground. We are impartial and independent, and we largely provide advice to governments, to commercial organisations, to clients, and other stakeholders around the world. So, Chris Thackeray this morning provided a quick outline of what CCS is. Just wanted to make sure that everybody understood what that is. CCS is a way of decarbonising those point source emitters, those heavy industries, those so-called hard-to-abate sectors, things like cement and steel, fertiliser, petrochemical refineries, etc. And when you've captured that CO2, you then need to be able to store that CO2 deep subsurface, typically below about 800 metres below the either land surface or the seabed. If we're going to use hydrogen in the future, certainly in the initial phases, much of that hydrogen will come from natural gas through steam methane reforming, and that will also require lots of CCS. And as Chris was explaining this morning, in the future, certainly in the UK and Europe, there's now an increasing recognition that CCS will need to be applied to create these carbon negative solutions, things like greenhouse gas reduction and direct air capture. So these are the sort of technologies that will be needed much more in the future. They're not being deployed right now, but they are coming on stream. Globally, last year, the Global CCS Institute, identified 77 commercial projects that are either active or in development now. So we can really see things moving forward very quickly. I don't want to dwell on this because Chris has already outlined this a lot this morning, but the key point I think to take away from this slide is that in the UK we are particularly well endowed with CO2 storage capacity. Our estimate for the theoretical capacity is that we have over 78 gigatons of storage capacity. That's a number that BGS has produced. It's not really changed over a period of time, despite us continuing to improve our knowledge of the seabed. But what that really gives policymakers and industry is the confidence that there is more than enough CO2 storage capacity in the UK for all of our domestic emissions, and indeed many of the emissions from Northwest Europe as well. You've already heard that there is currently a significant programme of funding for CCS in the UK, with a number of projects now taking FID, which is really encouraging, including two of the first CO2 storage projects. There's also a recent second licensing round that's been announced by the UK regulator, so we'll see in the summer of this year more projects coming on stream. But what I want to emphasise is it can take a long time to get from those initial storage licenses to an operating storage project, and our estimates say that that process can take up to 8 years, in some cases 10 years. And that really is a key message, is that if you want to have CCS in Thailand in 10 years' time, you need to start identifying your CO2 storage right now. I'm not going to go through this slide, this has already been described this morning, but just to say that we're applying CCS on cement plants and on power stations in the north of England, and we've got 2 projects ongoing now on CO2 storage. So what we try to do is we try to answer those basic questions, the questions that you might have around how much storage capacity there is it safe, what happens if it leaks. These are perfectly legitimate questions. We've spent our research time trying to answer those very questions. And that really goes to the heart of what we need to do to inform the public around informing that CO2 debate around CO2 storage. So just an example, we have a UK storage atlas. This provides a free-to-access tool for anybody to use in the UK, and this gives information on an individual storage sites. In this atlas, in this map, this online resource, you can all access it. Please Google it a bit later and look at it. There are over 600 individual sites now identified. So we really have world-class geology in the UK, which has really enabled us to drive CCS forward. Knowing where that storage capacity is, however, is not enough. We also need to know that it's going to be safe to store the CO2. And I would always advocate that we should undertake this risk-driven appraisal, this risk-driven investigation of this geological storage to identify and reduce those risks. And I think this is a really important aspect of the work that we do and many others do. We've produced things like these, this diagram here that you can see on your screen now is a summary of a workflow we've developed as part of a large international consortium for CO2 storage appraisal, which is driving the reduction of those risks and reducing uncertainty with CO2 storage projects. Just to give a flavour of the kind of activities that are required in such a risk assessment process, one of the things you might want to know is if your faults, your fractures in your geology are not going to move when you inject CO2. When you inject carbon dioxide, the pressure in the deep subsurface increases. At some point, if you keep increasing that pressure, you might get some fault reactivation. That might cause you some problems in your reservoir. It might cause you some problems in a larger scale as well. So we've undertaken research that have tried to map those faults and then done some simulations to predict the stability of those faults as you inject CO2. And this is part of the challenge we've got now. Whilst we know that individual storage projects are easy to develop, and well, not easy, but they can be developed, actually one of the challenges now is as we scale up CCS in the UK, as we inject CO2 into multiple locations in the subsurface, things like this pressure increase are becoming more and more important. So we're doing quite a lot of work in that area. In terms of the actual monitoring processes itself, how you try to reduce the risk during the actual operations of a project, obviously we need to do very, very good site selection and very, very good geological appraisal. We work with many or some companies in the UK who are actively developing their CO2 storage projects right now. We act as an impartial peer reviewer for some of those projects to, on behalf of the regulator, to give both the regulator and the storage developer confidence that they're addressing all of the right challenges in their subsurface, all of the right risks, and doing the right kinds of studies. So we're very familiar with what it takes to get a CO2 storage project from a theoretical concept to a practical project. You really require to look at multiple scales in the subsurface. This is quite a challenging process. You have to look at the pore scale processes, you have to look at the reservoir scale, and indeed a more regional scale as well. Just to give you a flavour of this, the reservoir scale image in the middle of your screen there is from Sleipner. On the left of your screen is the actual observed CO2 plume, and on the right is our predictions of what it should look like. Now they're pretty close, but they're not the same. And that is a challenge, and we have to communicate that discrepancy, that uncertainty, to the regulator to show that even though the predictions is not quite the same as the observed, nevertheless the CO2 storage is perfectly safe. That's a key aspect of the licensing process that will be needed to be undertaken. I've already mentioned about the regional investigations that are needed. On the right there at the bottom are a couple of images looking at the pressure response. We're injecting CO2 into the Bunter sandstone. The Bunter sandstone is a very large geological formation in the southern North Sea. Many of you might have heard of the Teesside project and the Endurance field that is located in this sandstone formation. What we've been doing is looking at that wider regional pressure response to understand how that might be impacted, not just by the Endurance project, but by several other projects that are coming on stream behind Endurance to also inject CO2 in that same formation. So our role is really to try and help understand that, help de-risk that, if you like. Of course, it's really important, as we've seen at Sleipner and many other projects around the world, that you are able to monitor your CO2 storage project correctly. Baseline data is really fundamental to that, of course. You need to be able to compare what you had when you first started with what you get when you start injecting the CO2. There are many, many different techniques you can use that give you different information. Some of that information is absolutely fundamental, and other are perhaps, let's say, nice to have, or are useful when you need to address certain monitoring aims. And I've listed a few of those on the slide here. We, on behalf of the IEA Greenhouse Gas R&D program, we operate the monitoring selection tool for them. This is an online, free-to-access tool that gives you a complete list of all of these different monitoring techniques based on your basic project definition. And this is really useful, and we know this is being used as a kind of audit tool to select monitoring MMV plans, monitoring plans for CO2 storage projects. So just to conclude then, my final slide really is that all this information that I've kind of run through today very quickly, I appreciate, is information that we are very keen is in the public domain. It informs policymakers, industry and society of the benefits and the scale of possible CO2 storage. And we think that's really important, particularly when you're at the beginning of a journey through CCUS. You need to build confidence with all of those stakeholders. You really need to do that through the pre-commercial development, assess those risks. The UK really sees CCUS as an economic opportunity, as you heard from Chris this morning. And BGS, we operate to help support all of that storage policy development and those commercial projects. So with that, I will stop and my time is out. So thank you very much for your attention.
Thank you very much, and big round of applause. Thank you very much once again, Mr. Jonathan Pearce from British Geological Survey. We've learned quite a lot, and yeah, I would say what a remarkable speech indeed, where we can see that so many techniques available, and though we have, it was quite a challenge, as he mentioned earlier, about how to communicate and also monitor and utilize data as well. So many areas which we will touch upon more in the panel discussion in a bit. All right. So up next, ladies and gentlemen, let's please give a big round of applause to welcome Mr. Rasmus Bjørngaard, Chief Business Officer, Saltforce Energy, to continue the session. Please welcome.
Thank you very much. And now for something completely different. We are not fixing what's there, we are making something else. We are making nuclear reactors. Small modular nuclear reactors, maybe you heard of it, is the next generation of nuclear. The ones you may know, there's like 450 of them in the world today, are called light water reactors. They're all good and fine, and we should continue to use them. They are carbon-free. It's a clean way of having what's called baseload energy. I know this is a very wide audience. We have very expert people within energy here, and we probably also have some that are not. So I'll try to give you an introduction to what we do, and at the same time, it's an introduction to small modular reactors. There's different variations of this technology, and you will hear about one of them. In our opinion, of course, one of the most promising ones, maybe the most promising one, especially in the longer run. This is where things are heading, but it's already happening today. So what you will see in the 30s is the next generation of nuclear. And what I will talk about today is the way we do it. So we are developing this at the moment. And we're working with GPSC, which is part of PTT Group. Now, the headline here is the most scalable and inherently safe solution. I'll explain what that means. The problem we know already, and it's been alluded to before today. One thing is the climate problem, where 20% of it is what we often hear about. That's the power, the electricity. But there's the 80%, which is not electricity. The hard to abate, the energy that goes into industrial heat and so on. That is very difficult to do something about, with renewables. I come from Denmark. It's a country where we have a lot of wind, and that's great because we are blessed with really bad weather, so we have a lot of wind. We should continue doing that. We should continue doing all of these things, but there's places where that's good. We do need a base load, and nuclear energy is very good for that. So think about this not as either or, but more as what is the right combination, including CCS, as we just heard about. Now, we address the whole pie that you see here, and then very importantly, and I'm happy to hear that more expressed today, there's a clear connection between the level of energy consumption and the level of prosperity in a country. So thinking that we can stop using energy, that's a no-go. We will use more energy, and we will also use more fossil energy. So even if we had seen things progress, still the major part is really black, and there's a long way to go. Our solution is on a boat. It's not because we want to sail around. It's not because this is about ships. It's because it's a great way to make things scalable. We are manufacturing power plants on a shipyard, and I will come back to how that works. But just think about this. This is about powering, giving energy on land. It's not about ships. Our power plant, it looks like this. It can come in different sizes from 200 to 600 megawatt approx in jumps of 100 megawatts. So our reactor is 100 megawatt electric or 250 megawatt thermal for those that are into the details. We load it with nuclear fuel, and then it runs for 24 years without refueling. So you load it once, and it runs for 24 years. Why do we do this? Why do we use molten salt? One of the main reasons is the safety case. And now is a good time to just mention that this is a technology that was proven already back in the 1960s. So this type of technology is not sci-fi. It has been running for 4 years, producing energy. We are taking it to the next stage, which is making it commercial and scaling it up, making sure that it can work for this longer time. That's not trivial, but we do know that it works. Why is one of the main things here that, as I mentioned, is the safety case. Existing nuclear is safe. Let's not get confused. What you know about Chernobyl, for instance, is a catastrophe out of the Soviet Union. It was a non-protected, non-secured nuclear power plant. That does not exist today, luckily. That doesn't mean, though, there is a theoretical risk. It's very, very low risk, but there is a theoretical risk of a meltdown, and that risk is an issue for public opinion. That is one of the main reasons why politicians and the public in general really like this next generation of nuclear, because we know that by the laws of nature, this cannot melt down, it cannot explode, you cannot have a release to atmosphere, so you can live next to it knowing that this simply cannot happen. Even if somebody on purpose, let's say a terrorist attack or something like that, it's still going to be really, really hard. But let's say it somehow happens. Make a hole in this reactor, and some of what's inside comes out, it will become a stone. Why does that happen? It's because we use something called molten salt. Molten salt is a salt, like you eat on the egg in the morning maybe. It's a different kind of salt, but really it's hard when it's cold, but when you heat it up to 600 degrees Celsius, it becomes liquid like water, and that's what we have inside. If you break a hole in the reactor, it comes out, it becomes a stone again. And of course you have a radioactive stone, but it doesn't get spread. So that's the safety case, and that matters for the public opinion, and it matters for cost. We don't need all the safety systems because you would make systems for nothing. And we remove the liability, so all the insurance issues and so on. We get something that is more in a category of, say, a chemical plant, industrial plants that you already have in different places. And of course you need safety around that as well, but it's a whole other level. You can also reduce the safety zone to a few hundred meters instead of 30 kilometers. So safety case is one of the main things that drive our reason for making the next generation of nuclear. The other is rapid scalability. So as we have heard several times today, the challenge we have ahead of us in terms of climate is huge. And scaling so that we actually can deliver these power plants and do something about it is not trivial. And building nuclear power plants, as they are traditionally, are huge projects that takes years. Now this can be done on a shipyard, on a manufacturing line, in a place where they're used to building big things rapidly. We can actually build 600 megawatt of nuclear power every week with the current capacity on the shipyard that we are working with, and that is Samsung Heavy Industries in South Korea. So we work with Samsung Heavy Industries and Korea Hydro and Nuclear Power. That's our two consortium partners. KHNP, Korea Hydro and Nuclear Power, already operate 26 nuclear power plants in South Korea. They've also exported to UAE, the Baraka plant. They really know the game. And of course, here in Thailand, we work with the different local stakeholders, most importantly, GPSC, who is a big, as you probably know more than I do, because many of you, or most of you are local here, is a very important player both in Thailand and in the region in general. It's a company that really know what energy is and what it takes to build big systems. So that's the other thing we do. We are leveraging also an existing supply chain. And this is how it works, and it will be super brief. The red part is where the fission process happens. The salt goes around in there. You can see the salt down to the left. It's the green stuff. It's in the solid version, and when it's liquid and inside the reactor, it becomes like water. Then it goes through a number of heat exchangers for safety and drives a turbine and produces electricity. And here you see a couple of pictures from our labs where you can see how we are down to the left simulating different things. You see one of the prototypes in the middle. It's a chemical reactor, so we do a lot in these glove boxes where we have protected atmospheres. We use microscopes to see very precisely how materials react and so on. And in addition to our commercial partnerships, we have a number of partnerships within the academic and scientific world that is very important. We have to prove everything, that everything is safe. So we work closely with national labs and universities all over the world. Here's a few numbers. If we made a project, say here in Thailand, it could look like this. And for those of you who are into the details of energy, you can see that this is a great business. And it's important to know and remember that this is it's a baseload technology. And again, we need baseload because we can turn up and down the energy consumptions as we want, not only when we have, in case of intermittent power, we need to have both. So all in all, this is a realistic way of producing power. It has been done before. We base it on existing supply chains. You can see that LEU stands for low enriched uranium. That's existing uranium supply chain. It's safe, it can't explode, cannot melt down, it cannot pollute the atmosphere. It's a flexible solution. We use a modular approach where we build on the factory and distribute with a power barge. So remember, this barge is not sailing around. It only moves the power plant from the factory to the location, and then it stays there for 24 years. So we still power land. Of course, you can also do things on the sea, but that's not our main focus. Short delivery times because we are building on a factory line, and we also can get the quality up because we're on a factory line. And then we have a scalable product. We can mass produce. The unit economics are great. And we manufacture and operate it together with well-established players in the industry. Thank you very much.
Thank you very much, Mr. Rasmus Bjerregaard from Salfors Energy. Big round of applause. Well, thank you for sharing something that is completely different, really, and it's like a new definition of the word nuclear, the next generation nuclear with those the safety case and also the rapid scalability, volume and costs are Very interesting indeed. All right, everyone, and now it's time for the final sharing of this session. So please give a big round of applause to welcome Mr. Tadashi Sumida, Group Manager, Mitsubishi Heavy Industry Limited, on the stage. Please welcome. And this is the ammonia co-firing.
Hi, everyone. I'm very glad to have an opportunity to introduce our ammonia co-firing technology. So, that's a key to decarbonizing coal boiler and stable power supply. It means, for example, if we replace half of coal to ammonia, it means that we can reduce half of carbon dioxide generated by the coal. And this shows about fuel ammonia. There are 3 points. One is ammonia's calorie is very low, and also combustion speed is also low. So it means ignition and flame stability is challenging. And also, ammonia have nitrogen. So suppressing nitrogen oxide is very important point. And third one is a very important point. Toxicity requires safety and regulatory considerations. And next is a schedule. From 2060, we start basic research. And at around 2021, we got a Japanese fund. We call Green Innovation Fund. And we start burner development and also feasibility study for actual unit demonstrations. And end of 2024, we already finished to burner development. And it means that we can offer concrete retrofit proposal for low ratio, such as 20% ammonia co-firing can be provided. And about high co-firing ratio, now we plan to demonstration around the 2030s. And also, for low co-firing ratio, we already had conducted 11 feasibility studies for many customers. Maybe some of customers will proceed to next stage. And in Thailand, at the BLCP plant, we also conducted 20% co-firing feasibility studies. So we can provide ammonia burners in response to BLCP's schedules. And next shows value chain. Of course, we have to consider at first production, blue ammonia or green ammonia. Then we have to consider transportation, maybe overseas transportation. And at the power station, unloading pier have to be established. And also a huge storage tank and vaporization system we have to install. And finally, we can burn ammonia at the existing power station boilers. And we, MHI, can handle this power generation area. And from here, I would like to explain about burner development. And we can apply 2 types of burners. First one is opposed firing, and another one is circular firing. And originally, we already have expertise in low calorific gas combustion and also low nitrogen coal firing technologies. That's why we can easily establish ammonia burners using single fuels. And the very important point is our burner can switch ammonia or coal. It enables greater flexibility in fuel availability. And if we apply a single stage, about maybe 20% or 2 stage 40, 3 stage 60, this, something like that, we can increase co-firing ratio. And our burner is a single fuel burner. left hand. So if we apply 20% co-firing, we need just only one stage of burners need to be modified. So it means cost benefit is very huge. And the next sheet shows steps of development. At first, we need to check ignition capabilities. And then we design burners and test it at a small furnace and brush up burners. And then using a large furnace to check burner combustion capabilities. And at this point, burner development itself is already finished. And finally, we check boiler combustion capabilities using computer simulation. And from here, I would like to explain the result. I'm sorry, I'm not so clear pictures, but located in midpoint, ammonia burner is installed, and upper side is a coal burners. And this frame is a coal frame. Ammonia frame is hard to see. And the result is right side. Ammonia co-firing, nitrogen oxide is reduced lower than coal combustion. It's a very good result. And the next sheet shows a computer simulation result. We check end of the furnace condition. And the nitrogen oxide also lower than coal combustion. And the unburned loss, this unburned loss means coal unburned loss is also reduced. And we already conducted 11 projects. From A to G is Japan's project, and overseas we have 3 projects, including BLCP in Thailand. And to achieve coal co-firing, we need to consider whole plant systems, including design additional piping route and also assessment of additional load on steel structures. And we need to check existing auxiliary systems such as fan or environmental systems. And finally, we adjusting operation parameters. And safety is most important. And there are 3 stages we have to consider. First stage is leakage prevention measures, including material selection, corrosion protection, seismic design, and piping joint design, something like that. And the next stage we have to consider is leak spread prevention measures. So including early detection and leak spread suppression in case of ammonia leak. And the third stage, damage prevention measures, planning for safety and rapid neutralize ammonia to prevent harm to people in case of leakage. Consider these 3 stages. We put a barrier or screens around the potential leakage point, such as a valve or something like that. And if there are some leakage, liquid ammonia will be ventilated to the boilers, and liquid ammonia will be burned at the boiler. And in addition to ammonia co-firing, we also can offer such as a fuel conversion to LNG and others, and also we can offer biomass co-firing or biomass fuel firing. And also we have carbon capture equipment we can provide. And the summary. So we have very many experience, and now we already developed well-performance ammonia burners, and now we can provide our ammonia burner for commercial use, including BLCP in Thailand. Thank you so much.
Thank you very much. Big round of applause for Mr. Tadashi Sumida from Mitsubishi Heavy Industry, ladies and gentlemen, of course. And that wraps up the individual sharing session. But up next, everyone, after we've been introduced about, of course, the CCS, I would say one of the best practices from the UK, and also the SMR, one of the most promising one, and yes, the ammonia co-firing as well. Now that we've got the picture of what it's going to look like, what it's going to be like, so I think it's now time for a panel discussion with our three distinguished speakers. So please join me in welcoming our speakers on the stage once again, Mr. Jonathan Pearce from British Geological Survey, also Mr. Rasmus Briangor, Chief Business Officer from Saltforce Energy, and Mr. Tadashi Sumida from Mitsubishi Heavy Industry. Back on the stage again, please welcome. All right, so first of all, after we've been, we've heard quite a lot, we've learned quite a lot. I really have to say that we truly appreciate of what you've been doing. And yes, things are moving very quickly, and now that we are in huge need of clean, reliable energy, so it's my honor indeed to do the job of the panel discussion right here. So first question, we will do like the round table, I think about 2 or 3 rounds. So we're gonna start with the first one about core technology and case study. So I'm going to start with from Mr. Jonathan Pearce. Would you please, from BGS experience, of course, and for BGS for over 190 years, what are the fundamental geological differences between CO2 storage in the UK and also here in ASEAN or in Thailand?
Yeah, thank you. So I think the UK is particularly well endowed with its storage capacity, as I was trying to explain during my presentation. We have a very mature oil and gas industry, which has developed a lot of knowledge of the deep subsurface. But I think what's really beneficial in the UK is that a lot of that knowledge is now shared publicly. It's in the public domain. And that gives us a lot of opportunity to then think about new applications like CO2 storage, where we can use that data for the benefit of these future sectors. So I think that's what's really important. I think the other aspects to CCS in the UK, and perhaps let's think about the North Sea in a slightly broader context, is that we have around the North Sea almost like a coalition of countries that are working together to develop CO2 storage projects. So they are working, they're developing their own individual projects, but they are constantly exchanging knowledge and information. We collaborate with colleagues in Norway and Denmark, in the Netherlands and in France, those countries that rim the North Sea. So that, I think, is a real positive benefit. And I see those as sorts of activities where Thailand can really benefit from that collaborative approach and also that sharing of knowledge as well, I think.
And what about, let's go to Mr. Briangor, talking about the SMR. So molten salt reactors are often described as the 4th generation SMR. So what fundamentally differentiates 4th gen SMR from today's?
There's quite a few things. One of the things that are most obvious in the small modular reactors is the small. And it's also at the same time a little bit confusing. So what's really important here is the safety, and that is directly related to the technology. So when we use, in our case, molten salt, there's also some that use gas-cooled and metal-cooled, liquid metal-cooled. The idea here is that the technical principle in the actual reactor is very different. And we have to become a little bit technical here. I'm trying to avoid it, but it is a mix of the fuel, the uranium, and the actual coolant, in this case a liquid salt, where in the traditional reactors that is split, and you call them light water reactors because they use water as a coolant, but there you have the uranium separate. They are in these sticks inside the core of the reactor, and that's also why you can have a meltdown. You can have a situation where where there's not enough coolant and the heat gets too high and you get a out of control chain reaction. You cannot have that when you mix the fuel into the coolant, and that is a coolant with a negative temperature coefficient. So actually, if the reactivity rises, it will automatically reduce, or if the temperature rises, the reactivity will reduce, and thereby it's stable. And then there's a number of other features around it that are resulting in an inherently safe reactor that, by the laws of nature, cannot melt down or explode. We cannot have this pollution. So that, I think, is the most important. There's a number of other things as well.
And where does the molten salt technology offer the clearest advantage, like compared to the fourth gen?
Yeah, so it's hard not to be a little bit biased on this one, and I think there will be other opinions. The molten salt is often perceived as the kind of end goal. And some people think it's harder, and we should take other steps before. We don't, because we have it working already. And it has, as I mentioned in my talk earlier, it has actually been running for 4 years already back in the 60s. And it's a matter more of controlling the corrosion inside the reactor to be able to scale it up. And that we have under control. That's one of our main IP.
Thank you very much for that. So as I mentioned earlier, that this session is like 3 completely different things. So from CCS, from SMR, let's go to Mr. Tadashi. From your experience at Mitsubishi Heavy Industries, well, how technically mature is ammonia co-firing today, especially for existing coal-fired power plants?
At worldwide, we already supply 5,500 boilers, and based on this experience, we have originally a well-established technology for low-calorie gas combustion technologies. We already have, and also we have low NOx coal combustion technologies. Based on these technologies, now we developed ammonia burners for ammonia co-firing in power plant. That's why we believe our ammonia burners well matured, and we can supply these burners as a commercial use.
I see. So that's about core technology and also case study. So let's go back to Mr. Pierce once again. Before we talk about the collaboration models and the industry ecosystem, would you please give any case that you'd like to mention, like for Thailand to benefit from CCS?
Any case?
Yeah, any case, a case study, yeah.
Yeah. So
get a picture.
Yeah. So the CO2 storage programs that we've got in the UK have been going for quite a long time now, and they're developing a real understanding now of both the storage capacity, so just where the CO2 is, but also what the risks are, as I was explaining in my talk. I think one of the really important aspects of this is to really share that knowledge and work in partnership between industry and the academic community. And we've done that a lot in the UK, and I can see that starting in Thailand as well. So I think that's really, really encouraging. I've been here talking to various groups for a week now, and I've learned a tremendous amount about the ambitions for Thailand in terms of CO2 storage, and I think you're in a really good place right now, but momentum needs to build and work in partnership, I'd say.
So yeah, we are moving towards the same goal, but yes, things are moving very quickly at the same time as well. So now, talking about the collaboration models, which is very essential. Yeah, it is essential indeed. So what types of collaboration do you see that are essentials to make CCS work at scale?
Yeah, I think that is a really, really good question. I think the collaboration works at very, very different levels. So clearly you need to collaborate between industry and, let's say, the public funders or the government, let's call it the government. Different departments within government need to work together. In the UK, we've kind of centralised our CCS activities in one single department that enables them to take essentially full ownership of the delivery of CCS, and Again, that's something it's something that Thailand can think about. Collaboration between industry and government is absolutely fundamental. I think we all know that. The other scale of collaboration is between countries, and I mentioned that previously, and I think that actually something that can be really beneficial. We do that a lot across Europe. We definitely work in partnership. There is an element of competition in terms of trying to provide the most storage capacity. I think we're starting to see that. Maybe we'll see that in the ASEAN region as well. That can only help to drive down costs, of course, so that's also good. The other collaboration, which I think is really, really fundamental, is between both the government, industry and the research community. Again, here in Thailand, there's a very strong research capability that can really help to answer some of the fundamental questions about CCS and those as you're starting along this journey. And finally, I think perhaps the single most important is collaboration with society. So I'd really strongly advocate engaging with both local communities that might be asked to host CO2 storage programs, but also at a much broader level. And we've done some research in that. It's not easy. Getting those messages right can be challenging, but I think that's absolutely the most important thing.
Yeah, indeed, and we totally agree. Working on this kind of thing is no easy task, but also collaborating as well, right? Yeah. So thank you very much once again for that. So now let's move on to Mr. Bianco for SMR. So what collaboration model has proven the most effective acceleration for SMR deployment?
Yeah, I think that's probably where the three of us will probably be similar.
Indeed.
These big projects, the collaboration with the players on the ground is super important, and that's both for governments and for private institutions. I mentioned we are collaborating with GPSC here in Thailand, and I think that kind of collaboration is really showing the lead. It's important that a player like GPSC and PTT as a whole take a step forward and say, we believe in this because you are looked towards, and there's a little bit of hen and the egg here. For instance, the regulatory authority will look to, should we look into this? We will only spend time and resources on this if we can see there's a future in this, and that is of course often the private institutions that lead that. That's where the business is. So that's what we see. We also see many countries taking lead themselves. They understand, they have big ambitions in the field around, of course, being sustainable and in increasing their energy use. And I think maybe one difference is here that this next generation of nuclear could equally well be a Southeast Asian lead as it could be a Western European or American lead. And it's here that the big increases in energy use happens. And I believe that Southeast Asia has many of the elements that are required, such as shipbuilding, such as the ability to construct big things, and as well the demand. So for us, Southeast Asia is actually the primary market, even though that we're coming from Europe. I'm a lot here, and I'm a lot in other countries as well. And as mentioned, we work closely with South Korea. So I think this collaboration is essential. And I think it's essential to start early and be visionary and accept that sometimes it takes some time.
Any example of collaboration that's happening in Europe, maybe?
In Europe, there's also a number of projects there.
I'm sure.
But I actually think that the main areas where things are happening is here and in the US, in terms of taking lead in investment. We are together with two other companies, the main companies, well, maybe only one other company, the main ones in Europe.
Thank you very much for that. And now let's move on to Mr. Smita. Well, of course, the same question about the collaboration model. So what is the most effective one between industry, government, and technology providers as well?
So I think there are three important key elements. First one is well-structured carbon tax or carbon trading scheme have to be in place. That's the first items. Second one is a very important point. Not only ammonia, but also hydrogen. Generating cost need to be reduced by some technology improvement or something like that. And also transportation and storage, these kind of things need very huge cost. This cost reduction is very important. So this is the second point. And the final point is, especially in early stage of ammonia co-firing, how can I say, commercial use, CapEx or OpEx need to be supported by some schemes such as a long-term PPA, especially for the carbon reduction schemes. So these kind of things need to be considered, I think. Yeah.
Like for the commercial use and so many areas that should
Yeah,
considered. Okay, so next we now we've got a picture about the collaboration model that from three of our speakers right here. So let's dive deep into that a little bit. Let's start from Mr. Tadashi Sumida first. Well, what regulatory challenges arise when building like ammonia with coal?
For ammonia combustion, important point is environment. So even in ammonia co-firing, boiler outlet, it means the outlet of the stacks condition need to be equal or better than coal firing, I think. That if so, we can keep environmental conditions lower than regulatory limitations.
Okay, so the environmental area that you've touched on, and how have you been? Have you seen them successfully addressed? I mean, these challenges.
Yeah, our laboratory test, or based on laboratory test, we simulate boilers condition. This result is better than coal firing. So if you apply ammonia co-firing, exhaust gas condition is better than now.
I see. Well, thank you very much. And now for Mr. Bianco, of course, after the collaboration model, now from your experience, same question, the regulatory foundations that are essential to enable the fourth generation SMR.
Yeah, I think that may be one of the main challenges in next generation nuclear. Nuclear is highly regulated. It's the most regulated probably sector, at least in the energy industry and maybe in general. So sometimes we talk about okay, we may have some technical challenges. We're not so concerned about that. There's things to be done, but that is just nature. The law of nature, we can handle that. But the law of man is sometimes less predictable. And there it is super important to work with the regulator in the different countries. It's something new. In Thailand's case, Thailand is a new nuclear country, so there's a learning curve, of course. And in our case, it's also a different technology, so the regulator needs to learn about that technology, and that is only fair that requires an effort and takes some time. So regulatory is a big topic in general. It is something that luckily things are happening very fast, and it has been increasing the speed, and that was why I mentioned the US before as a leading role, because the US has, with some presidential decrees last year, really taken a step forward. And I think very much what is happening is that the US is playing catch up with China, because China is moving a lot as well in next generation nuclear. So what we are seeing is really a race on this next generation of not just nuclear, but energy technology. And I expect that we will see, whether it's with us or not, we will see a whole new situation in energy in the middle, late 30s. That's where we really can see it, but it will already start happening in the first half of the 30s. It's other conditions. It's another logic that we get in, where we can get baseload at big scale, very practical, and clean.
I see. Well, of course, that hearing about these new technology, actually it's not new because it's what is happening right now. So we can see that so many areas that we have to work on more and more. So what practical steps are needed to accelerate the implementation in your idea?
I think it's very much having the vision here. So there's always this issue of, for our, and I think it's general, but very much for nuclear, you need government. You cannot do this because it's so regulated. You cannot do this without government. And governments are not necessarily made for inventing new things and taking the first step. So that is a hurdle. And I'm happy to see that actually Thailand is not the country that brags most about its ambitions, but we see different countries, and we believe very much in Thailand being very serious about it. It really takes the steps and implements them. But in general, we see that people are having the ambitions that are required. And we are now so long into the crisis of the climate crisis that people have and countries have realized that the first wave of solutions were not enough, and they have started looking for the next wave. At the same time, we have had an accelerator, which is super, super important. It's very important in all of the world. Where I come from, it has become extra important because we are basically at war with Russia, right? In Europe. And it's been clear that we were dependent on Russian energy. It also become clear that going to only renewables is not enough. Maybe you heard about what Germany has done and how that has hurt Germany and Germany's industry. And there's a realization that we must be we cannot be so reliant on energy. Europe imports 50 to 60% of its energy. Now we're trying to get off the Russian energy, and that just means going to LNG, which is much more expensive, and from the US instead. So we have 3 times as expensive electricity as the US, and that's not competitive. And here you have a different situation, but the basics are the same. You want affordable, independent, sovereign energy. And that's a security concern, and it's a affordability, industrial competitiveness concern. So these things are really moving the needle, and we are seeing that across policy making in the systems across the world.
Thank you very much. Yes, that's absolutely clear that collaboration is the key here to address those concerns, right? So thank you very much once again. And now this question is for you, Mr. Pierce, from working with a government worldwide. So what are the key elements and a country must have in place?
Yeah, so I think it kind of continues a little bit from the previous discussion around the need for regulations, and having that clear policy is fundamental, and consistent policy that can really help to give confidence to industry when industry are being asked to invest their money in a new technology. They need to be confident that that policy is going to remain in place. The regulations are also really important. So in the UK and in Europe, we have a regulatory system for CO2 storage that's been in place now for almost 2 decades, in fact. It's now being tested in anger, if you like, tested in practice. We're permitting CO2 storage sites. And it's fair to say that over the last 5 years or so, we've learnt quite a lot about the most efficient ways of bringing those sites to operation within that existing framework. So that's that framework, and getting confident with and understanding that framework is really important. If you're trying to go from a single project to a larger industry, however, you also need standards, and you need let's say, an understanding of how that industry can operate between itself. So having those guidelines, having those standards, having a rule book for engagement again is really important. And we've seen this in the UK, and there is efforts in Europe now to also develop these kinds of standards or rule books of engagement, really. So I think they're the kind of like key basic elements that you need, as well as going back to the basic knowledge of the potential scale of, in my case, CCS for Thailand or for the ASEAN region, I think. Yeah.
I see. So allow me to ask, if Thailand were to begin like CCS today, what would be the most logical first step from a geological storage perspective?
Yeah, so I mean, I'm bound to say this really, I think, from what I've been saying this afternoon, but the most important thing that I think Thailand needs to do is to really understand how much storage capacity you have. That needs to be shared, particularly with policymakers. So although I talk a lot about regulation and policy and rule books and so on, there's no point doing that if you don't have confidence that you've actually got enough CO2 storage at scale. So that's really the most important first step. I'd really like to see a CO2 storage atlas for Thailand being developed. I think that would be great, both onshore and offshore. And there are opportunities both onshore and offshore in Thailand. I think they're really important. I'd like to see a lot of engagement with the public on some of these risks, because it is, without a doubt, the CO2 storage that creates the most concern within the public. I mean, we've seen that in Europe. I've seen that in the UK, and I mean, we have direct experience of local communities being very concerned about storage in their backyard. So communicating an understanding of the risks, communicating an understanding of the knowledge and how we approach those storage sites to make them as safe as possible, I think these again are going to be absolutely critical. So these, I think, are the primary first steps that I'd like to see being taken here.
Thank you very much. So, of course, the engagement with the, I would say, stakeholders, shareholders, and the elements in the whole ecosystem. And of course, you need to have standards and understanding. Thank you very much for that. And now for Saltforce, of course, Mr. Bob Youngott, looking ahead, 10 years, 15 years ahead, how do you envision the role of Gen 4, the fourth generation SMR?
Yeah, not surprisingly, I think that it has a big future. So I think we will see a situation where this is common and where we have integrated systems widespread. Again, one of the things that are with Generation 4 is that is a difference to Generation 3 is that you can put it much closer to population and to existing infrastructure, simply because it's safer. It's safe in a different way. I don't really want to say safer because the other thing is really safe. It sounds like it's not. But it just has a different safety profile that makes that possible. And then it is a leaping point that we can scale our production, that we can deliver in 3 years, and also at other price points. Today, one of the reasons why nuclear power plants become very, very big is that you are interested in scalability, that you want to get the price per megawatt hour down by having a lot of megawatt hours per site. We get that scalability not through size of each site, but by scaling widely, by manufacturing. And as you know, that is how cars got cheap, that solar cells got cheap, that everything got cheap by manufacturing, and you need centralized manufacturing for that. So what we are seeing, let's imagine we are in second half of the 30s. At that time, we'll already see this as something we are well accustomed to, not afraid of. And it becomes more a question of how do we scale this out, and people will position themselves towards something known. Today, it's something that many believe in, but of course there's a lot of unknown. So it's really very, very different. And if we, for whatever reason, don't succeed and there's no nuclear generation 4, first off, nuclear needs it. to exist, and we really have a problem with our clean energy and also the sovereignty and all the other things I mentioned. It's a huge problem without nuclear. Then I also think we will start seeing the Generation 5, the start of that, and that is reuse of fuel, for instance. I mentioned you put on the fuel and it lasts for 24 years. After those 24 years, actually we only used 5% of the energy in that fuel. It's hard to imagine how much energy is in uranium. It's only less than 5% enrichment, and still we only used 5% of the energy, and it ran for 24 years. So we can actually recycle it, and that will be the next wave. And by that, we also reduce the waste to almost, something negligible. So the waste problem that you may have heard of, and I didn't get any question about that, but that's often the question, that's very handleable as well.
So clearly, apparently, the development process and also studying is not going to stop. And yes, safety is quite key talking point. So communication plays a pivotal role in terms of to get us to that leaping point. Thank you very much. And now for Mr. Sumida, well, how do you see the ammonia co-firing evolving in the future, like 5 years?
So regarding the renewable energy, such as solar or wind, some area in the world not suitable for this kind of renewable energies, including Japan. Such place, coal-fired power plant is still main power source. So this area need to be applied ammonia co-firing for realistic solution to reduce carbon dioxide. So I believe at first a small co-firing rate will be applied for such kind of place as a realistic solutions. And maybe 10 or 20 years later, hydrogen society will come. At that timing, maybe switch to the hydrogen. But between now to hydrogen society, ammonia will be support to reduce carbon dioxide, I think.
I see. So I think there are a lot to look forward to in the future, right? So now, ladies and gentlemen, let me just wrap up this session with this final question. I would say the final round, a very quick and short one, because may I ask each of you to give only one sentence, all right? Only one sentence, because we have so many young generation, young innovator, and also the policymakers right here, and also tuning in online as well. So would you please give one sentence for them watching here or live through online? So let's just start by maybe Mr. Sumida, and back to you, please.
So I believe a carbon-free society we can achieve. So we need to small step to achieve them.
Never stop exploring and achieving. All right, thank you very much. And your turn.
Become an engineer. We need them.
You are in huge need, okay? Engineers and future engineers out there, okay? And now, Mr. Pierce, please.
Yes, and if you don't want to be an engineer, be a geologist. That's even more exciting. But what I would say is start now. CO2 storage research is needed now because you'll be ready in the future to deliver it. So, yeah.
So everyone, let's be future ready. And big round of applause. Thank you very much to all our speakers and the panel. It's been very helpful indeed. Thank you very much once again. And may I ask three of you to please remain on the stage as we are going to proceed to the next session, which is going to be the photo session. But it is clear, ladies and gentlemen, from this panel discussion, from technology to traction, CCS, SMRs and ammonia co-firing that are no longer merely technologies of the future, but essential tools that are already being applied in real-world setting to address today's energy challenges and reduce carbon emissions. All right, so, and now, ladies and gentlemen, allow me to invite on the stage Dr. Yuthana Suwannashod, Executive Vice President of Innovation Institute, on the stage for a photo session. Please welcome. So yes, for this session from the we have the individual sharing session. Also this panel discussion, it has been really useful indeed. Thank you very much for those insights, informations, and yes, inspiring words for all of us, not just only us here, but a lot tuning in online as well. Young innovators and also policymakers out there. These are especially for you, and you are very much needed. Okay, now the video, so it means that we can give a big smile, move a bit, right? Okay, so, all right, in 3, 2, 1. That is absolutely amazing. So, ladies and gentlemen, once again, big round of applause. And thank you very much, all our distinguished speakers. Thank you very much, Dr. Yuthana Suwannashod as well. Thank you once again. Wow. So, as we can see there's so many techniques, so many approaches, and cutting edge technologies we have now. We are moving forward to the same goal, right? The better and clear future with clean and reliable energy. All right, everyone, and up next we have a session that's just as exciting. It's called Digital Sparks, Real Shifts, Real World Impact, Case Studies in AI and Digital Solution Implementation. And this session explores how digital technologies and AI solutions are not only streamlining workflows, but also generating tangible environmental and social outcomes, driving real-world change for a more and more sustainable future. And for this TED Talk session, we have 3 speakers coming up on the stage because we have 3 main topics that we are proudly to share with you. We have Mr. Nopadon Singiyam Paisan Suk, partner ERM Thailand. And up next will be Dr. Warodom Kampanchai, CEO and co-founder Autotech Global. And last but not least, we have here with us Mr. Sunil Patil, Senior Director, Solution Consulting at Aspen Technology Inc., Singapore. And for this TED Talk session will be conducted both in Thai and English as well. So please, we provide simultaneous translation for you. So feel free to contact our staff at the registration area if you need a headset. All right, so everyone, let us begin with our first TED Talk of the day, methane detection by drone and AI. And this session will highlight the importance of methane detection and the critical role of AI and drone technologies. So now please give a warm round of applause for Mr. Nopadon Singiyam Paisan Suk, partner ERM Thailand, on the stage. ขอเรียนเชิญคุณนพดลบนเวทีค่ะ
โอเคครับก่อนอื่นทาง MC ได้แนะนำชื่อผมไปแล้วก็เดี๋ยวผมอาจจะสั้นๆแนะนำเกี่ยวกับบริษัท ERM นะครับว่า ERM คือใครนะครับซึ่งวันนี้เนี่ยสิ่งที่ผมจะพูดก็จะเป็นเรื่องของการ detect นะครับตัวมีเทนโดยใช้วิธีการต่างๆ
using all kinds of techniques, mainly using AI and drones. Let's talk about ERM, my company first. We are a consultant in sustainability mainly, and ERM itself is one of the sustainable consultant, one of the largest one actually, which I'm very proud of. We have office in every continent in the world. more than 150 offices, and we were founded for around 50 years. And we have been supporting through our network in almost every single industries for a long time. Oil and gas was one of them too. For this range of service that we have, a big range, especially for sustainability, I'd like to focus on service regarding carbon reduction. For carbon, EIM has been providing carbon accounting support and solutions, as well as identifying projects that can help releasing of carbon into the atmosphere, and cost curve, marginal calculations as well. And these are all global experience. In the regions, of course, we have been providing services to major oil and gas in the industries, including PTT. And that's why we're here today. We have been providing service to PTT for around 20 years. Now, methane, why is it so important? For those who don't know yet, let me kind of give this information to you. It's about global warming. Everybody have heard of that? The world has become warmer because of these different kind of gases. Mainly they call it greenhouse gases. Methane was one of the greenhouse gases, and now it's important, right? And it also has an ability to destroy the atmosphere worse or faster than the carbon dioxide. So it's one of those bad guys for the atmosphere, And companies in industries, that's why it's only rational that they would focus on reduce or get rid of their methane emission. And of course, it can also help reduce their cost of the business, for sure. Methane can be used as a fuel as well. So it only makes sense to all these industries to reduce their methane reduction and or reuse them as fuel for energy generation. And what about others outside the companies or industry? We call them stakeholders, which is all of you here. So we have the sector has been under pressure from even investors. Now investors, besides looking for their returns in shares, they care for their lives as well. They don't want their business that they invested in to do any harm to the environment, right? And this methane data quality has become more crucial because it reflects the money in their pocket. Carbon tax, for example. Thailand will have that too, I guess. Now, when it comes to finance, when it comes to money in different people's pocket, now it has become even more important, right? So, and for consumers, clients of those industries, of course, they will also help create same kind of pressure to this industry, like, okay, you have to tell me and the whole world rather how much you are releasing, do the emission, how much you emit to the world, to the atmosphere, and then it will become standard. Speaking of the latest standards, OGMP 2.0 is oil and gas methane partnership 2.0. This is one of the latest UNDP standard. And now when it is UNDP, it means that now kind of the whole world have to have this same kind of standard in reporting, and that includes transparency as well. Well, excuse me, I really have to go a little bit deeper and deeper. So for methane management, we have 4 kind of rules or 4 pillars of how to manage your methane. The first one is identify and or detect. Now that after you have to kind of be able to count it how much has it been released. After that, you get those numbers, and you know for a fact you have to report it with transparency to the whole world, or at least to your stakeholders. And of course, now the whole population around the world, they would love to know that, because it affects the tax, affect your stock price and everything. And of course, that includes every companies in the stock market, including PTT. So here's the graph and the terms: identify and detect, quantify, disclose, and improve. That's the fourth step. We have several ways of doing these things, right? And we have always coming out with, people, industries, other consultancies, coming out with all the new ways over time to do all these four processes: identify and detect, quantify, disclose, improve. We are talking all a whole range of technologies, infrared technologies, sensors technology, new sensors in device, ground sensor, whatever sensor you can think of. One of the things that have becoming even more popular is the leakage detection in remote area. This needs different kind of new sensor. Even in aircraft and satellites being incorporated into these four processes for the either detection, quantify, whatever, in all these four processes. And of course, whatever you want to use, it will depend on the size, your budget, the size of your business, the size of your sites. If it's so large, you're probably gonna need aerial or satellites, right? For that, to do some screening or whatever. But if you want to go down to equipment level, it has to be OGI device that different kind of sensors that I was talking about. So and of course it will give you whole different range of size of data and accuracies and all sort of things. In order to leverage the right mix of technology to maximize your detection efficiency, you're going to use just everything that you see here, from low, from the detection threshold on the x-axis, from low, medium to high, and on the vertical axis, it's bottom up or top down. You can have, you can see the icon of the cameras, to drones, to vehicle, to aerial, then to satellites, and you can see the whole range. And that's why we need AI to help, because you're gonna get a whole lot of data. Some of the system might be equipped with AI from the get-go, which is great, but you're gonna have to be able to wisely use your AI effectively. For example, to use AI to help dealing with the gigantic amount of data. That's one great help using AI. And in the future, so that you can know your place and reduce the future emission of your methane, if that's your case. And putting all these data into a different kind of format of reports. OGI, maybe Thai local standard of reports. AI can also help with this, so that you don't have to hire people to think about what type of graph to show. We just use AI. Now let's look at the case study that we have done. Let's start with ERM, with us. ERM has only recently acted as an advisor to oil and gas company, names to be withheld. They're in European countries. This company, though, they have their own system in collection of data and the collection, quite mature system where they can know, where they already knew, and they have the system in place of how much they emit. We'll talk about emission now, and they aim to be a net zero. And then later on, they have become member of OGMP, and PTTOR was part of this group as well. And with all these technologies and new standards, they are looking for newer techniques, better techniques to detect and to calculate these numbers so that they can, so that easier and faster for them to do this report. So ERM went in to help to look at the system and help them to come up with better ideas, better ways of collecting, manipulating, calculating, producing reports, gather all this data and make use of them, literally. So we did studies, we work with different units in the business. The next step right now would be the drilling operation in all their offshore rigs, and there will be installation of SEMS or continuous emission monitoring, CEM SEMS as well. This is where we are right now. Anyways, so a little bit more, but probably last slide from me. You can see that for oil and gas alone, we have big players like BP, Chevron, ExxonMobil. They have their own technology and also incorporating AI for quite some time. BP, for example, they have started using drones to detect methane from 2019 already. Chevron itself have been using sensors, a laser sensor or LiDAR that is equipped with the drones or airplanes or fixed wing to assess their assets, how much methane they have released. And AI have already been part of that from the beginning, and it helps calculate, interpret all this data into a more actionable data. ExxonMobil and Shell has already used satellite, aircraft, and drones, and everything, sensors included. And in the end, AI will come in to kind of gather and synthesize all these data and produce them into a kind of a more human understandable reports or data sets. So what have they said similarly? And up until last year, they all said they have reduced a lot of methane, maybe like 60%. And they aim into looking into 2030s, they aim to reduce it down to up to 80%. And Shell was aiming to also do similar things, and they have set the goals to reduce methane to the closest to the net zero in 2030s. This is how much AI can help. These are real case studies that we have helped them. My last message here for my talk is that whatever it is, drones or AI, if you can use it well, it helps you a lot. It might sound advanced, but it's not, because from the case study, a lot of the big names already use it for quite some time, and the technology itself has been on the development over time and cheaper over time. This is important for me to tell you. And for other industries sitting here, you have no way but to study them. We have new laws coming out as well. That's where I want to end my talk.
เลยค่ะยังขอ
Thank you
เรียน
so
เชิญ
much.
คุณนพดลอยู่ด้วยกันบนเว
Please
ที
remain on stage. Please welcome Dr. Yudhana Supachok to come up here from PTT Innovation Institute to share the photo and provide some souvenirs for you. Thank you so much. This is Kun Nopadon from ERM. You can see it is a very interesting case study. Big round of applause. And next, this is TED Talk style speaker. And next will be
ERM Thailand. And now, ladies and gentlemen, our next TED Talk takes us into another dimension of AI with this topic, AI for efficient building operations, when building are no longer just spaces, but intelligent systems that learn, adapt, and also use energy more efficiently. And here, where AI plays a key role in reducing energy consumption and lowering carbon emission as well. So this session will demonstrate how AI is transforming traditional building management into real-time, data-driven decision making. So, ladies and gentlemen, please join me in welcoming on the stage Dr. Warodom Kampanchai, CEO and co-founder Autotech Global. On the stage, please welcome.
Okay. Thank you so much. I think I better present in English. Okay, so for Autotech Global, we are representing Thai startup, but actually we are in Southeast Asia market now. We in Hong Kong, in Singapore, in Malaysia. So what we do, we try to develop the platform so that we can what is called a self-drive the buildings. I think when we talk about efficiency, autonomous, we think about self-driving car, but how about buildings? For now, we operating the building like MBK. We have some sensor running in Paragon. We have some sensor running in Bytech, Circuit, M-Quartier. So it's like everywhere that we're working now. So before I get started, I just want to show you something that overview of what we do.
Can you hear it? The pulse of our planet is racing, feverish, exhausted. Buildings breathing out carbon, consuming energy uncontrollably. Inaction equals destruction. At Autotech Global, we see the challenge, and we have engineered the answer. Our mission is to drive the world toward net zero, harnessing the power of AI and IoT to elevate ordinary structures into smart buildings. Introducing Alto Zero Waterside Chiller Plant Optimization, AI-driven control that transforms efficiency, saving building energy consumption by up to 30%. Alto Zero Airside, AI-powered solutions for optimal HVAC performance and indoor air quality, lower electricity costs, reduce carbon emissions, and promote sustainable practices. Airside and waterside integration, the perfect synergy powered by an AI-driven system, unifying your HVAC operations to minimize energy waste and maximize savings. Alto Digital Twin, a virtual 3D reality of your asset, mastering space management and pinpointing maintenance needs instantly. Alto Multi-Property Management, centralized control for your entire portfolio. Benchmark efficiency and track every branch, all from a single screen. And all of this is powered by the passion of our expert team. Fusing deep experience with AI and IoT, we innovate for a smarter planet, expanding across Southeast Asia. We are here to make net zero a reality.
Yeah, so that's pretty much overview of what we have done and what we're going to do. And if you've seen, I think for this event, it also a net zero event, a carbon neutral event, right? And if you go to Bytech Bang Na, you will see like the screen like this, showing exactly what is carbon neutral event, what contribute to carbon emission, and how we gonna compensate it with carbon credits. So we make it transparent. It's not only Bytech. You go to Queen Circuit. They say they are now the first venue that doing this. So we think, okay, efficiency is not the thing that in the back end, it can come to the front end and provide transparency from event to building to city to the whole country, and when we export on something. So yeah, so you will see like everything transparent. We connect chiller plant, we connect like airside, we connect everything that use energy, and even like garbage or food that consume in the event. So many events, when you go there, you will see like they do it carbon neutral, transparent carbon neutral. So I think the demand that we got also driven by global standards. So we can see like okay, hotel forced by like Green Globe, forced by buildings. Many buildings in Thailand now doing white score and smart score, the smart certification for buildings. We see like factory. I think Thailand we target 2050 carbon neutral, but if you talk to some factory, they said 2030. We have only 4 years left, 5 years left to work with them and to push them. So when we talk about efficiency, I mean, okay, in Thailand we have BEC, Building Energy Code, but in Singapore they call SLEP, Super Low Energy Building. So to become super low energy building, you have to like avoid, reduce, replace, and maintain. So many practice nowadays like we replace. We think okay, save energy installing solar. It doesn't save energy at all. It just you're switching the cost. You're switching the source of energy, right? So we have to do all this. And when you see the element, you can see like chiller plant, AI, optimization, analytics, and we're gonna see a lot of green standards and green logos that you want to put on everything you do, even you do catering. So there's a blueprint for modern smart building. I mean, before we think about okay, build a building, having aircon and make it like space cool, whether too hot, too cold. No, doesn't care, right? We just okay have aircon to run. But I think for now the equation of running properties it changed. It's not driven by only money. It's not driven by only reducing energy. We're talking about carbon. We're talking about human. So we put human algorithms inside, and you're gonna see not only digital AI. You also gonna see like physical AI, like robotics that work on this smart building. So for Autotech, we have like Auto Hero, try to like boost productivity of human that work with Auto Zero that we have the IoT connect to properties, and I think AI is pretty much the foundation. I think the things that make Tesla different from other brands is like Tesla putting GPU inside the car, having AI model running. The same thing, we sell GPU. We put NVIDIA GPU for real buildings, running AI model to optimize. The same thing happen for properties. We have a lot of these standards. You're gonna see that Thailand doing this LEED, well, smart score, white score, or even reset standard. So now I think the demand is like everywhere. Every city, every country has buildings, but we still, I think, less than 0.5% having building automation that has AI embedded. I think the opportunity is huge, and you have the app store for your phone. You may have app store for your car. The building like this, like Paragon, if they want GPT to help them operate this space better, where do they download the app? I think it's hard, right? So we're building the app store for properties as well. So now many people are talking about digital twins. Then you're talking about AI. You're talking about GPT and the controls, autonomous control. So we're building the platform so that it can be an app that can be installed. So these are the customer that we develop. So actually it's a lot more now. So we manage over hundreds of buildings. But this year we target around 500. We're working on the platform that can connect to around 30,000 properties. So this equation that we gonna solve. I mean, it's not only energy, but it also like every system inside the buildings inside the property, inside the factory has to work together. Building, it's the same thing like your home. You buy EV, you have one app. You buy smart lighting, you have another app. You buy aircon, you're gonna have another app. Building, same thing. The camera does not connect to aircon control. The sensor does not connect to anything. So this is what we solving. I mean, we integrate everything together and we make use of this data. So, and also not only Thailand, I mean, all the country have the same issue. I think in Malaysia, one of our customer is Petronas. Petronas has money to pay for electricity, no problem. Their problem now is carbon. You can pay for electricity, you can pay, it doesn't matter how much they use, but it matters how much carbon they emit for their properties. So, yeah, I mean, for now, I think, okay, many organizations doing carbon accounting, but when you know carbon footprint, what next? And what's gonna be the end? So we are the company that explain what next and how to reduce and how you can compensate, disclose and certify. And for the technology, I think many of buildings nowadays pretty much like a car. Your car, gasoline car might not connect to internet. The same thing like buildings, but when you buy EV connect to the cloud. And when you buy maybe Tesla has AI to control. Building the same things, but now we are at the building 6.0, where you have BIM, you have twins, and you can do all this simulation. So we also laid the very first company that integrate Gen AI to building energy optimization. We use it for fault detection, automatic reporting, doing the controls. So these are the applications that in our app. Before, many buildings, they run chiller plant separate from their air side. Like this thing we call air side. What inside chiller plant we call water side. So we integrate this to work together. We have the brain, inside is NVIDIA GPU, the install app. So whether the existing building, existing properties can install all this app. So this is like the one that the operator can toggle. Okay, whether you want to run it manually or you want it to self-drive. By self-drive, it select and control the machines for you to optimize the performance of the plant. We went to Singapore. Singapore doesn't have numbers of engineer or technician who want to work inside the property. They asked us, can we do AI chief engineer? They don't want to hire human. They want to hire AI as their chief engineer who never reside from that building. So we have this paper with NVIDIA that we develop the stack, we test our models. So we have to put it to test. There are many models open. Okay, you have Gemini, you have OpenAI, you have DeepSeek, but those doesn't understand engineering. It doesn't understand your home, your properties. We need to train it so that it understands your property, test it, and make it run in real life. So this is what we call AutoS.
Teams of experts, years of
AI
experience,
chief engineer
analyzing thousands
embedded
of data.
into your property.
What if your team had instant access to expert-level analysis? Introducing AutoAce. AutoAce gives your team instant access to specialized knowledge and advanced analysis. Analyzes real-time and historical data with native access to our BMS Alto Serum. Full understanding of building semantics, identifies risks and inefficiencies, and provides actionable advice instantly. Preserving memorized institutional knowledge that remains through staff turnover. Accurately references engineering documents, equipment specs, and maintenance logs. Are you ready to experience the future of building and...
Yeah, so that what we see. So now we also super lazy to ask AI. Let's AI recommend. When you wake up, AI will recommend you. So this is one of the sites in Singapore. So we have many properties and we also lazy to manage one by one. We manage them all. So now we connect to this year we are able to connect to around 30,000 properties. So they also stack that we're talking about BIMs, we are talking about digital twins. We integrate AI and twins together so that we can manage, we can build twin for any property. So this one is the net zero energy building, belong to the Ministry of Energy, Thailand. So we have BIM. So we convert BIM into twins, and then we integrate IoT data into these twins. So we're gonna launch it by mid of this year for fully functional twins. So you can see all the information, you can see all the mechanical, electrical, and all this layer, and also like thermal comfort. So the future, it's not only one building working. I think it's gonna be like multiple buildings working together as a city. So we also help utility develop a demand response platform that we can connect to many properties and ask them, okay, when they need to reduce the peak demand. So we develop this platform as well. So I think utility in Thailand also like have the initiative. Right? So the building in the future need to be able to interact with the grid, and when it interact, you need AI for controls. So these are the case study we do. So we run MBK. So we help them save like over $1 million a month for energy. So we running St. Regis, we running like factory in Freon, like Denso, Great Eastern. So this one in Singapore is a insurance company. So Central as well. Yeah, so that's pretty much it for me. And all the video you've seen is made by AI. And we spend only less than 10,000 baht to make those videos. Thank you so much.
Thank you very much. Dr. Warodom, please remain on the stage for a photo session, and allow me to invite on the stage once again Dr. Yuttanath Wanachor, Executive Vice President of Innovation Institute, to present the souvenir to Dr. Warodom. And yes, clearly we've seen why buildings matter in decarbonization, and also those real case examples. Yes, so once again, this is from energy waste to measurable impact with AI and digital. Big round of applause, ladies and gentlemen. Thank you very much, Dr. Yuttanan. Thank you very much, Dr. Warodom. Well, yes, really have to say that we do look forward to those series and multiple series of multiple buildings and collaboration in the future, in the near future. Thank you very much once again. And now, up next, the final TED Talk of the session will take us into the oil and gas industry, everyone, where organizations are facing growing challenges in cost efficiency, also safety, and increasing pressure to reduce carbon emissions. So in this context, of course, digital technology is no longer an option, but a critical enabler of transformation. So let's see how digital technologies can drive real and tangible and measurable change toward sustainability. And now, please give a big round of applause to welcome Mr. Sunil Patil, Senior Director, Solution Consulting at Aspen Technology Inc., Singapore, on the stage. Please welcome.
Thank you. Hi, good afternoon. I said last, but I hope it would be very helpful to understand what are digital technologies we have. So slightly different topic than what we have been hearing, but I think essentially in my discussion I'll be focusing on how AI and digital sustainable solutions will help specifically process industry, oil and gas industry. My name is Sunil Patil. I'm a chemical engineer by background, and I'm a professional solution consultant for process industry, and mostly focusing on digital solutions and sustainable solutions. A little bit background about Aspen Tech. I'm sure most of you know, is a leading process modeling and simulation company. It's been in the industry for 45 years, but I think more so our focus is now, last few years, is how we help collaborate, achieve net zero targets together with our partners and customers, right? So if you see the journey, right, we started in 1970 in MIT University in US, And since then, Aspentech evolved as a process modeling, simulation company, optimization, and then of course we expanded to the entire asset optimization, and then now we are part of a larger automation company which is Immersion, right? So since March last year, Aspentech has become fully owned company of Immersion, right? That's a brief history. Now, what are the challenges you see in the industry, right? We have been hearing about sustainability since morning. Yes, of course, that's the key thing which everyone wants to achieve. Everyone wants to reduce the carbon footprint. Everyone wants to use the green energy, sustainable energy, right? But I think from an Aspentech point of view, right, we really see there are dual challenges. One, of course, you see growing demand of resources, right? Because of course population is one thing, plus the growing demand of a lot of other things. For example, plastic demand, fuel demand, energy demand is going up, right? Standard of living is going up, and at the same time, while we address all of the needs or we meet the demand, the other side, the pressure is on us about the sustainability. That means how to reduce the carbon footprint, how to reduce the emission, and so on and so forth. Now, in my discussion, I'll be discussing with you how Aspentech as a company can help to address this dual challenge. So if you can see some data points here, right? Now, if you see the global population, right, that's around 2020, mid of 2020 was about roughly 8 billion, and it is projected to be going up close to 10 billion by 2050, right? Now, electricity, of course, is going up. Energy demand is going up, right? So what it really means, overall, around 50% energy demand will grow up by 2050, right? So it's a huge, right? While we may supply the energy by various sources, but at the same time, if you look at on the right-hand side, right, I think the other key thing here is, it's not moving? Oh yeah. So other key thing here is basically how do I address this sustainability things, right? So as I think including PTT Group, right? Most companies now targeting to have a net zero by 2040, 2045. I think majority of you have a target of 2050, right? Now, GHG reduction, greenhouse gas emissions, right? That's another key challenge which you have to address, and at the same time, the fossil fuel contribution to the global carbon or carbon dioxide emissions requirement. So overall, if you see, how do I balance between these two? One side demand is going on, and other side pressure is building on to address the net zero, right? Now, here is the key thing. Aspentech is uniquely positioned to address this, right? So we are pure play software company. And in historically, if you see us, right, we are a software company to address this profitability, we address the energy efficiency, and of course, improve the plant uptime and so on. But now we can proudly say that we are beyond that. We ourselves call as an industrial AI company uniquely positioned to address the sustainability needs, right? That means we combine our domain expertise, right, together with the AI ML technologies. You know, you heard a lot of technologies about that, and together with that, including our fundamental principle-based modeling technologies together with the AI, we try to address the industry challenges, and more specifically in this discussion, how we address and help to achieve the sustainability goals. Now, let me put it in a simple way, right? We heard a lot of things about sustainability, right? But if you look at three key pillars of the sustainability, first is resource efficiencies, right? We heard about that from other speakers as well. How do we address about carbon capture? How do we address about circularity? How do we address about the green energy requirement, especially green hydrogen and so on, right? Decarbonization, I think it's a hot topic. We heard a lot about that, right? And every country, especially there was a presentation in the plenary this morning, right? How UK has achieved that and what are their goals and how quickly they want to do that. And the other most important thing is the circular economy, right? So how do I recycle the plastic? What technologies are available, right? For example, we all have the plastic bottles in the room here, right? How do we recycle it, right? What are the technologies and all that? How do we overall reduce the emissions and waste, right? So let me elaborate these three key pillars with some examples, right? So as you heard, right, we focused on oil and gas, chemicals, upstream, and of course in the downstream refining companies. So these are certain examples, success stories, case studies from AspenTech where we collaborated, help companies to achieve variety of the sustainability goals, which includes reduction in carbon footprint, then improving the energy efficiency, reduction in CO2 emissions, right? I won't read all of them, right? But if you can refer some of them, for example, Shell, right? We helped them, collaborated with them to develop a new solvent for carbon capture, right? Before me, there was a presentation on MHI. I think the gentleman left here, but we also collaborated with them as well, right? And then, of course, Chevron, BPCL, Lotte, S-Oil, and many others, right, where AspenTech solutions help them to improve the sustainability goals, right? Now, what are the pathways, right? Now, if you see the sustainability pathways in the industry, right? So today we talk, we hear a lot, and we target about energy efficiency. That's the most important goal. But at the same time, we are looking at other things which also links to sustainability, like water conservation, waste reduction, biofeedstock, so on, right? And needless to say about hydrogen and carbon capture, that something is there. But at the same time, in the tomorrow, which is our near future, what we are also looking at about the recycling, right? I mean, of course, there are recycling technologies, but are they efficient today, right? Are they economical today? Then what are the new materials, which is more in terms of sustainable materials, right? How do we make sure that the sustainable materials are available easily, and of course, can we use CO2 itself as a feedstock, right? So let me talk few of these here. Right? To start with, of course, energy efficiency, right? Because as I said at the beginning, right, since we deal with oil and gas, chemical, process industries, right, energy efficiency is the key thing for us, right? Now, some of the challenges, as you see, energy intensity, which is typically measured in refining or oil and gas companies, the EIA index, right? Then site-wide energy consumption, steam is the biggest consumer in energy industry, energy waste for unplanned equipment outages, and so on and so forth, right? Using AspenTech solutions, as you can see at the bottom, right, there are a variety of solutions which actually help you to achieve a different level of benefits, right? Improving efficiency at design stage, improving the energy consumption in the operations as a digital twin, then of course in asset performance management in terms of reducing failure and things like that, right? So overall, we have helped achieve up to 30% improvement in energy efficiency. That's a significant. Now, let me supplement that with a success story, right? This is again a Middle East company, Kuwait National Oil Petrochemical Corporation, KNPC, right? They have actually deployed AspenTech solutions for their refinery across the refinery site. So we call it as a refinery-wide modeling for improving the energy efficiency. Okay, so you can see the solutions and other things. For example, market-leading Aspen HYSYS has been used to model this plant and identify the energy-saving opportunities. But most importantly, the significant saving in the carbon dioxide emissions, right, which is almost like close to 60,000 tons per year, right? This is an example from a refining company from Middle East, KNPC. The other example, as you can see, is emission management, right? So one we talked about is energy. Now let's talk about emissions, right? Now we heard a lot about this emission. I was listening many others presentation this morning, and emission is one of the things, right? In oil and gas industry, right? I think you heard about boiler, right? Any furnace, right? Any equipment, when it talks about energy, you need a fuel for that. And when you burn the fuel, of course, emission has to be there. It will be there, right? Now, for some examples, certain challenges, right, to control emissions, right? Inefficient measurements, manual processes, limited capital investment, especially in the newer technologies and so on, right? Now, using our digital solutions, we help to automate emission reduction. We help to report the transparency across the plant, across the enterprise, and minimize the flaring. That's most important, right? If you see any plant, you always see the flares, right? How do you minimize that? What technologies will help you to reduce the flaring system, Right? So overall, using this Aspen solutions, definitely we help to reduce the emissions or improve the emissions, right? Again, a case study, an example from a refining company. This is from India, Bharat Petroleum, right? They have deployed Aspen Tech solutions for emission management, emission measurement, and also the monitoring and control as well, in a real time, right? So this is an example of a real-time digital twin for emission management and emission optimization or monitoring, right? So here, of course, the absolute numbers are not there because some companies do not publish the actual data. But as you can see, they save reporting time and meet the CO2 targets, and most importantly, made the compliance, right? Because when it comes to CO2 emission, compliance is very strict. In every country has their own norms, right? So here, as I said, it's a digital twin example where this dashboards which they develop. Of course, this data coming from the process models of Aspen technology, which is Aspen HYSYS, and of course, comparing that with the real-time emission from the plant, right? So whatever emissions, actual emissions in the plant versus predicted by model, which was compared, and the operators actually took the action to reduce the emissions by, of course, the optimization methods suggested by the model. Now, another example is biofeedstock, right? We talk a lot about that. For example, ethanol blending, right? And several other things, right? How do you leverage this biofeedstocks and availability of biofeedstock to generate the biofuels, right? Now, for example, now biodiesel, right, is something you might be hearing a lot. Or how do you use ethanol within the gasoline, right? What percentage you can leverage that, right? So all of this actually help to again improve your sustainability, right? So looking at increasing demand for fuel, what government policies are there in respective countries for biofeedstock, and what are the renewable alternatives available, right? So Aspen Tech solutions, right? Again, I want to give a success story example here, right, from a refining company called Hindustan Petroleum. They actually modeled a very new innovative technology, right, for biodiesel, right? So basically it's called green diesel blend, right? In which they achieved 5% green diesel blend with this new technology for HDO, which is what hydrodiesel characterization. Now, this is a classic example how one can actually use the digital solutions for biofeedstock selection, biofeedstock optimization, or even the validation of new technologies, right? The next is green hydrogen. I think this is something, a lot of things were being, in the industry, people have been talking, right? Can we have a green hydrogen, blue hydrogen, purple, or a lot of colors and etc. But is it have an economical solution today to really generate a green hydrogen, right? I think the major concern today is still a cost and safety, right? Now, that's how you see in the challenges here, right? How to improve the production scaling, right? Because most companies who are still investing into this are at the stage of either pilot plants level, or they are still looking at how to optimize the production cost, right? Then how the different innovative technologies been used, right? So those are the things. Now, to address that, basically, the digital solutions would help, and I would explain that with an example, a company called Air Products who collaborated with us to improve their overall operating cost for the green hydrogen production. Right? And finally, I will supplement with one last thing is about carbon capture. I think this is a key hot topic. Again, a lot of things have been talked. Again, the major challenge here is how to improve the efficiency of carbon capture with the different types of amines, right? A lot of amines are available, but I think most companies are investing to develop their own amines, combinations of amines or mixture of amines and so on. So Aspen Technology Solutions help to actually simulate, to improve the operating conditions, enhance the efficiency, and so on. And this is an example of a company called Carbon Capture, where we collaborated with them to develop a new solution for the carbon capture or CO2 modeling. Finally, as a company, as I said, we are industrial AI company who provides a software solution for oil and gas industries for all types of sustainability solutions. You saw the example of energy efficiency, emission, carbon capture, biofeedstock, as well as the CCS and CCUS, right? So we do provide you a library of examples, pre-built examples, right, where you can choose and pick based on what you want to achieve, what you want to do, what we want to actually deliver. Even it can be in emission, it can be in hydrogen, and you can start from there, right? And as a summary, right, our mission together with our customers, our partners, we accelerate your journey of sustainability, right? We help collaborate with most of our customers, leverage your existing investment with us, because most companies in oil and gas use our software. It's more about collaborating in enhancing on net zero goals, right? And our mission is actually, as you can see, help our customers to run the plant safer, greener, longer, and faster. Yeah? Thank you. Thank you.
Thank you very much. Well, Mr. Sunil, we have to say that those success stories have been truly inspiring indeed. And now, ladies and gentlemen, please welcome back on the stage Dr. Yuthana Suwarnashore, Executive Vice President of Innovation Institute, on the stage for a photo session and also to present the souvenir to Mr. Sunil Patil. Thank you very much. Really have to say that this has been such a useful and also inspiring session indeed. Yes, and from all three TED Talks and Digital Sparks Real Shifts, we can see clearly that this is the heart of the point. So thank you very much once again, Dr. Sunil Patil and also Dr. Yuthana Suwarnashore. So it is very clear, ladies and gentlemen, that digital technology is no longer just a tool, but it is all about the transition to a real, measurable and scalable shift, creating meaningful impacts across the whole ecosystem and the environment at the same time. So that is what we are doing, and the same goal, we have mutual goal that we are moving forward to นะคะซึ่งทั้งหมดทั้งมวลนี้ที่เกิดขึ้นไปเนี่ยไม่ว่าจะเป็นทั้งในส่วนที่เป็น TED Talks นะคะรวมถึงค่ะ individual sharing ที่เกิดขึ้นไปทำให้เห็นนะคะว่า point ต่างๆเหล่านี้คือ goal เดียวกันที่เรากำลังเดินหน้าไปด้วยกันนะคะเพราะฉะนั้นแล้วเนี่ยทุกท่านคะยังไม่หมดแค่เพียงเท่านี้เพราะเรายังคงมีอีกหนึ่งเซสชั่นเป็นเซสชั่นสุดท้ายของเวที Spark X นี้เลยนะคะกับหัวข้อ Pioneering Sustainable Futures นะคะหรือว่า Startup Showcase นั่นเองค่ะซึ่งเวทีนี้เนี่ยเป็นเวทีพิเศษนะคะที่จัดโดย Corporate Venture Capital หรือว่า CVC ของกลุ่มปตท.นะคะที่ผลักดันนวัตกรรมค่ะร่วมกับพันธมิตร Startup นะคะแล้วก็เป็นการสร้างแนวทาง Solution เพื่ออนาคตที่ยั่งยืนซึ่งสำหรับเซสชั่นสุดท้ายนี้นะคะเราจะไปเริ่มต้นจากการถ่ายทอดภาพใหญ่ค่ะของคำว่า decarbonization ไปดูกันนะคะว่าสำหรับคำว่า sustainability และ decarbonization เนี่ยมันจะเกี่ยวข้องกับเราทุกคนยังไงเพราะเรารู้ว่ามันสำคัญกับโลกมากแต่ what's next นะคะแล้วยังไงต่อเพราะฉะนั้นแล้วเนี่ยทั้งหมดทั้งมวลก็จะนำเสนอนะคะโดยบริษัท Espresso NB แล้วก็จะตามด้วยการแนะนำ innovation จากแต่ละกลุ่มอุตสาหกรรมค่ะพร้อมกับตัวอย่าง startup นะคะซึ่งมีเยอะมากๆตั้งแต่เริ่มต้นนะคะจะมี Sustainable Aviation Fuel นะคะโดย Espresso NB ค่ะมาพร้อมกับ Startup นะคะกับ Clean Joule ถัดมาจะต่อที่ Advanced Low Emission Hydrogen นะคะโดย Top Ventures นะคะพร้อมกับ Startup ก็คือ Super Critical Solutions และนะคะยังมี Sustainable Chemical
Clean Joules and Espresso NB and then follow with Supercritical Real Technologies, and then Explore Venture with the nuclear energy, which is SAF energy startups. So we got rows of startups coming up next. Now let's welcome all of them. Start with Mr. Prempidi Kitiyatprakan, CEO of Espresso NB Company Limited, to start with his decarbonization and PTT Group
Capital, please.
Work that they've done together. So, hello, everyone here who's here and who's somewhere else, online or whatever. I'd like to spend 5 to 10 minutes to capture for you, why do we need to invest in the climate-related investment. This is something we capture from, for the last 8 years. This is like the highest 8 years of most rapid rising of temperature. The whole world has temperature has risen in general from 1.2 Celsius degrees Celsius, which is actually a big thing because if you think the whole world temperature is rising up and down, right? But you're gonna have middle average temperature to pretty much stay the same. That's what we thought and we expected, but no, the weather kept on, the world, the earth, the globe kept on becoming warmer and warmer. We started to see more ice, that from the both poles of the earth, of the globe, to start melting, and some of them never come back to reform as to become an ice again. So more melt, less ice. Less icification. So the situation is that weather become more severe and unpredictable. When it's hot, it can be so much hotter, extremely hot for a longer time, randomly as well. Heat waves becoming worse. The temperature was actually in certain place was 38, but it felt like 43 or 48, and that's some heat wave as a result. That just not just feeling, but and we also had severe flash floods and mudslides, earthquakes, big earthquakes around the globe. So it's like everything happened so sudden. Let's just take last year alone. So sudden, everybody's unprepared. Season wasn't acting like a season, So one of the major contributor is the greenhouse gas, according to science. In order to cope with that, to limit that, to handle that, there are things that science says we can do, and it results in different technologies coming up. Most of you already know. Some of them like to mention more electrification, more energy efficiency, less kind of burn for energy technology. So all the technology in the world right now, we like to say that all technology that we have right now is not enough, and it's going to be a way too slow and too hard for us to reach net zero in time that we set out as our goal. So we look at the goals as the world that we expect it to be, to stay in the limit of 1.5 degrees centigrade. We only have 4 to 5 years left, as a summary of all this graph, and that's why PTT Group in itself decided to invest more in newer technologies, innovative technologies from all around the world. We work with venture capitals, whoever that's supposed to, that they claim they have the technology that can help with this, to help us reach net zero. PTT has committed around $455 million US, around 10 billion, about 10 million US dollar, I think, so that we can hope to make new change to Thailand to reach safer and faster net zero goal. So, and that's why we have a series of venture capitals and startups to join us here, to come up here on the stage to say what they have to offer. Each of the startups here. And they all start with the first
นี่ค่ะอย่างที่เมื่อสักครู่นี้นะคะคุณ
companies.
เปรมปรีดีได้บอกไปแล้วทุกท่าน
Thank you so much, Mr. Prem PD. You can see that why we're all here, and lists of very interesting startups and investment to come up here. It will be the startup showcase. We'll start with decarbonization in different industries. We will have representatives from CBC, from PTT, and all the startups to come up and do the pitch here. The first is about sustainable aviation fuel. We will have panel talk from Mr. Tipok from Espresso NB. and then we'll follow with Clean Chu by Mr. Mukund Karanchikar. He's a CEO and co-founder as well. And right now, please welcome Mr. Tipok first. Hello, everyone on the SparkX stage. Before we enter the showcase and talk about our sustainable fuel, let's allow me to call it SAF, SAF. Allow me to kind of create a better understanding why we're doing this and what it is. SAF. It might sound long and hard to understand, but it's very important. It's something happen behind the scene in aviation all the time. See, aviation industries around the world. One year we have around 35 million flights throughout the year, and you see, if you look up in the sky, you see, your chances are every time you look up in the sky, you see a plane, if not more planes. So they are releasing more than 1 billion tons of CO2. That's 2.5% of all CO2 released in the world. If we don't do anything, this number will double by the year 2050. So why cannot we reduce this emission? Well, I'd like to say that aviation industry is very hard to reduce and long time as well to reduce, because we have, and not that we haven't tried. We have been trying, with the new engine technology, combustion technology, hydrogen propelled, or even batteries of electric technology for propellant. But in order to reach net zero in time, it will be contributed mainly by SAF technologies. It is also a kind of fuel, but it has been produced by by different source. Maybe not by crude oil, maybe some bio or use of oil, or other bio regenerative or circular technology. We push this SAF into the same old infrastructure. If with that alone, we can reduce from 50 to even 90%. And SAF can be a main contributor for us to reach net zero, to even raise the importance of the issue. The US alone has been supported SAF by the tax credit incentives and other incentives. And EU themselves, they have issue mandate obligation as well, as you can see here. So Thailand alone has announced the use of SAF in 2 years ago, and starting to mandate that at least 1%. That's a good start, better than nothing, which is an important good step. 1% has to be SAF among all the aviation fuel. For PTT alone, we have our goals to use SAF in all aspects, including building the capacity of creating or producing SAF its own on its own, looking for technologies and things like that, and all the ecosystem being built for SAF as well. Now let's look at the policy in different countries which is important to drive the SAF accessibility and prevalence. Let's look at the technology landscape, which is results of the policy of each country. One of the technology that is ready for commercializing is where we can turn from the used cooking oil and vegetable oil and turn them into SAF. This is the one of the best right now. We should be able to use this technology to produce, but no more than 10% of all the SAF needed in the world. The remaining 90% will have to rely on newer technologies coming our way that will help plugging the gap, filling the gaps that is still needed so much. And the cost curve and the technology will be different. And Thailand alone would have to choose the next technological SAF technology that fits our context as well. One of the company that is coming up next is one of them, which is nobody else but Mr. Makun Karanchika from CleanJoule to come up and deliver his ideas and technology. Thank you.
Person in the last row, can you hear me fine? Yes? Okay, thank you. Thank you, PTT, for inviting us and your regional as well as global leadership in enabling decarbonization across various different multiple sectors. Aviation is very close to my heart because it is the hardest to decarbonize. And why is that so? Because the types of engines that we use on these planes, they use a very specific high energy density hydrocarbon called Jet A or kerosene that comes only from petroleum. Tipok mentioned prospects of people evaluating batteries, hydrogen. However, the long-haul transport will always remain on energy-dense hydrocarbons. So how do you then go about decarbonizing it? Particularly in an industry where the growth is unabated, aviation as an industry matters to the poorest of the poor. One sign of have you come out of poverty is have you taken a flight. Everyone here and around the world, regardless of their socioeconomic status, always remembers when you flew the first time, because it's very unnatural to human beings to fly. You will always remember it. So on one end, you have masses around the world coming out of poverty. On another end, you have people whose time matters a lot who fly only private. And everyone in between. So it touches every single life on the planet as we know it, and yet less than a third people around the world have taken a flight. So imagine if all of us have to fly at some point in future, the carbon emissions that will come from this sector alone would be so high. Therefore, the technology landscape that Tipok covered is inadequate since the decarbonization is limited to only 50%. What we need as a planet is 100% decarbonization, and the airlines want to do it, right? The airlines are very progressive when it comes to their attempts at decarbonization. It is for the rest of us to give them the toolkit. And the biggest solution in that toolkit is sustainable aviation fuel as a direct alternative to petroleum-derived kerosene. CleanJoule's journey of last 15 years has been enabling 100% SAF availability for our customers, that is the airlines and all of you who then fly on those aircrafts. The way to do that is you pursue superior hydrocarbons that will require way more than 6 minutes and 44 seconds that I have remaining in this talk to explain. But just note one thing, you need superior hydrocarbons to enable 100% SAF, which is what CleanJoule does. Just a quick word on our investors. Gen Zero is clean tech investment arm of Temasek. They are an investor. Indigo Partners is a private equity firm. They are an investor. Clean Hill Partners is a PE. Along with 3 different airlines, and the beauty of our airline investors is they are ultra low-cost carriers. Just these 3 airlines alone fly around 150 million people in 7+ countries on the planet very cost-effectively. It's our job to enable decarbonization in a cost-effective manner so that airlines can continue to do their business. And aviation is not limited to terrestrial, you and I flying from airport 1 to airport 2. It's also outer space travel. Lot of talk around putting data centers in space, people wanting to fly to outer space. And the way you do that, is you fly a rocket, you need superior hydrocarbons that are alternatives, which CleanJoule enables to double the payload of these rockets. Method of manufacturing looks very similar to what you would have almost any process industry. People at PTT, GC, TOP would readily relate to method of manufacturing. It uses one vessel to take biomass and make an intermediate material, another vessel that takes the intermediate material and finishes it into SAF, which then becomes a direct blend stock for Jet A, and at some point will become 100% direct replacement of the full tank. I'm going to skip this because there is a lot of math here and I am jet lagged. The feedstocks, right? So the next best available feedstock after petroleum crude. If you look at it, we are blessed as a planet where you have access to so much free energy in the form of petroleum crude. Biomass, on the other hand, is actually superset of that energy. You draw a black box around Earth, sunlight comes in, there is a lot of carbon dioxide, a lot of water. Ultimately, biomass gets produced whether you want it or not. That's why biomass-based SAF will always be a direct replacement in the near term, in the long term, in the bigger term, short term, all of that as we look into the future. And then, it's not a Thai phenomena, it's not a US phenomena. Countries around the world are putting forth regulatory frameworks. Tipok talked about regulatory framework in Thailand in terms of blending mandate. Around the world, there are blending mandates as the world will continue to advance decarbonization of something as hard as aviation. Thailand's jet fuel demand will continue to grow because economic development leads more flights. It's a very simple phenomenon. How does the picture look like for us in the country here? Those are all the residues of farming. You can produce about 10 billion liters of SAF for blending into your Jet A, or produce 10 billion liters and substitute Jet A completely, or export some of it. Air quality around Bangkok gets discussed a lot. I live in Salt Lake City, Utah, same problem. And the reason we all know is farmers set their crop residue on fire between December and April. And this has been happening for 3,000 years. So you take an average newspaper in Thailand and you say, oh, the farmers are being urged, do not burn your crop residue. Yeah, how? They've been doing it for 3,000 years. And then you say, oh, no, maybe it's automotive emissions. It's not. It's crop residue. What we need to do as a society is to have the will to help the farmers dispose of their carbonaceous feedstock by making advanced products like SAF. So it's no more just a decarbonization by flying airplanes. It's no more about having the global leadership in decarbonizing something that's as hard as aviation. It's also touching the very life of farmers. And they are loved in all countries around the world, right? Because it's very basic. We've been farming for 23,000 years as civilization goes. Very first rice farming records in Thailand are 3,000 years old. That's the industry you touch. When you say, please give me your biomass, we will make advanced products. And while doing that, we will set up manufacturing in rural parts of the country, thereby enabling higher income for those people and effectively connecting the old economies that are farming-based and advanced economy that would be decarbonization-based, that allows for airplanes to fly farther, higher, longer, much cleaner as we look into the future. The mandate, we covered the numbers, 1%, 4%, going up to 8%. And Thailand has demonstrated regional leadership alongside South Korea, Singapore, and Japan. And these signals are very important because they enable an industry. Anything that's in its infancy will always be, in the beginning, more expensive than what has been there for 250 years, called petroleum crude-based industry. we need to give time for the new industry to come together and at an ecosystem level enable cost-effective manufacturing. It's job of people like me to make sure the technologies are cost-effective when it comes to molecular transformations by alternative pathways. People like Prem have to make sure there is money available to do the job in terms of scalability. And then there is an ecosystem of regulatory frameworks that needs to be enabled. With that, I'll close my talk. A lot of things happening in Thailand, by the way. It's not just you and I talking about it, right? Whether it is PTT GC, Thai Airways, Bangkok Airways, the government signaling, all of that is happening very, very well. Again, thank you so much for giving me the opportunity to share my thoughts. Tipok, thank you for the invitation. Espresso and Prem, very happy I'm here. Apologies for the jet lag. I hope this came across as totally in English. You know, I'm Indian, so if I'm jet lagged, I start talking in different languages. So I'm glad the whole thing was in English. Again, thank you so much for the opportunity, PTT.
Thank you so much, Kun. Mukun, big round of applause. Yes, I'm sure you have so much more to share after a bit of a rest, maybe. And yes, we can't wait to hear more from you. Thank you very much once again. Also คุณทิปกด้วยเช่นเดียวกันนะคะต้องขอบคุณมากๆเลยค่ะสำหรับ innovation ที่น่าสนใจมากนะคะแล้วก็ต้องยอมรับค่ะว่าสิ่งที่เพิ่งได้ฟังไปเมื่อสักครู่นี้
Except that these are very important things that I have not heard before, because when the plane is up in the air, we never know what's happening, you know, behind the scene. The fuel is so important. After SAF, now we are moving on to another kind of energy for the future. It's advanced low emission hydrogen. And for this, no one will be more appropriate than Mr. Niwat from the new S-Curve from Top Venture, and follow with the startup named Super Reticle Solutions by Mr. Luktan. Please welcome Mr. Viwat first.
ก็สวัสดีทุกท่านนะครับ
Well,
วันนี้ผมก็
hello
ใน
everyone.
ฐานะตัวแทนของ Top Venture นะครับซึ่งเป็น
As
สิน
a
เชื่อไทยออยล์เนี่ย
representative
เรา
of
จะ
the
นำเสนอในเรื่องของการ
venture capital,
decarbonization ของอุตสาหกรรมผ่าน low carbon
I'd like to talk about the investment through low emission
ตัวไฮโดรเจ
hydrogen
นเนี่ยเป็น
technology. Hydrogen
ของ
itself
สำคัญมากๆเลยนะครับที่ว่า
is
เราใช้ในอุตสาหกรรมหลาย
important.
แหล่ง
How
หลายอย่างเลย
it's being used in many industries, in refineries, for example, petrochemical, or even cement factories and steel factories. All around the world, we have been using yearly 100 million tons of hydrogen, and it's increasing every year still. And right now, it's being produced by steam methane reformer technology. We use natural gas or coal, and of course, it produces a lot of CO2. This is old technology, bad for the world right now, right? Now that we learn, and we have to control the temperature of the world to increase no more than 1.50 centigrade. So how are we producing hydrogen with less CO2? In this technology, we have these terms that we use, and I hope this helps for those who are not familiar with this. Hydrogen has no color. You never know. So we kind of, divide them into groups. 3 colors for us. The first one is gray hydrogen. It means being produced by steam methane reforming, old technology, produce a lot of CO2, bad for the world. Another one is blue hydrogen. It's actually this gray hydrogen technology plus the technology where we catch the CO2 in midstream and we put it underground using CCUS. And the third one is green hydrogen, where we produce hydrogen with almost no CO2 being produced because we use electrolysis. And we use the electricity produced by solar cell or other renewable energies. And let's look at this graph on your right. You see by the color, green and blue hydrogen usage is on the rise in the last 5 years for 60% actually. If you look closely, you look at the green is eating up more and more space, right? So the world would love to move to the green hydrogen, hopefully. Next, for green hydrogen, as I said earlier, we use electrolysis, right? We have newer techniques that is commercially viable. 4 of them actually. I like to go a bit fast. You know, first one is AEL, alkaline electrolysis. Sorry. This is exists for more than 100 years. It's quite mature. There are some cons. Is that it uses a lot of very stable. It needs a very stable power, which is electric. You know, so some of the renewable energy feeds might not be appropriate. Next one is PEM, proton exchange membrane. We have a lot of PEM users around the world. This is like the upgrade over the AEL. It also has some cons, which the electrode that being used, it needs high price like material like iridium or platinum, which is, you know, rare earth. Next one is solid state electrolyzer cell, SOEC. This one is, to me, one of the best. Only a few things is that we have to operate at the around 800 degrees Celsius. So operating costs will be kind of high as well. The last one is AEM, anion exchange membrane. We combine AEL and PEM all together, where we can use renewable energy, and the electrode is using a cheaper metal. And this technology is one of the newest ones. It needs some more time to mature. So, in conclusion, we have 4 technologies, 4 challenges, 4 groups of challenges. They all have pros and cons. So, if you want to produce like really green hydrogen in mass, we need good players and new players. So the next generation of low emission hydrogen should be something where the membrane is cheaper. We have to have hybrid electrolysis. For the green hydrogen itself, we have many types here. I'd like to raise some of the kind of impressive technology for me, which is bioelectrolyzer. They use microbes. It's a TRL5 in the middle. So these microbes eats up biomass and then produce hydrogen. The next one is thermochemical water splitting. We use very high temperature heat over 2005 Celsius to separate hydrogen from water. And it's, of course, it's going to happen all by itself. Another one very interesting right now is highest on the top, which is membrane-less. Not even cheaper membrane, but membrane-less electrolysis. TRL4 to 6. It has no ion conducting membrane as a conventional electrolyzer. Can be operated at a much higher temperature and pressure. And this membrane, if it can work at around 300 degrees Celsius at 200 bars, which is way cheaper. So Thai Oil has been investing in membrane-less electrolyzer. We call it supercritical. This is a British startup. They can produce hydrogen at a really high efficiency system, which is the purity is at 99.99%. High efficient system, 46 kilowatt hour, and it happens at 200 bar. High pressure H2 product, so we can use at other industry without using any secondary compressor. Now let me close down at the quotes from Bill Gates. He said, if you want me to read, cheap and green hydrogen would be a massive breakthrough in clean energy. If you trust in Bill Gates, trust in us, right? So because he knows a lot, he invests a lot. Hydrogen is the only thing in the world when you burn it, all you get is water, right? So that's why he believes that it would be a massive breakthrough in the clean energy in the world. Well, I guess it's time for the video of these supercritical startups. Remember, they are doing their job right now is headed for, they are working on the membraneless technology, right? Now let's look at the video.
My name is Luke Tan. I'm the co-founder and chief product officer at Supercritical.
Hi there, I'm Matt Bird. I'm the chief exec and one of the co-founders of Supercritical. I left corporate world. I knew I wanted to do something that made a difference. Making a difference could be many, many things, but I knew that I wanted to do something that was not that corporate way of doing things. And so I very consciously left that world and went back to what I started my career, which was startups. And I enjoy doing something, working with small, engaged, intelligent teams, but actually working on something that's going to make a meaningful difference to the world.
I'm a chemical engineer by training. I worked with one of the biggest chemical companies and hydrogen companies in the world, and where I found purpose, where I found as though I was actually being useful, was where I actually realised what I was doing and where I was adding value. What I'm passionate about is making a difference, and in Supercritical, where I massively find purpose is in solving the world's biggest problem, climate change. Climate change is the biggest problem that the human race has ever had to solve. Never mind our generation, the human race. It's human ingenuity and pace of change that's got us to where we are in terms of this massive scale of problem, but it's going to be human ingenuity that gets us out of it as well.
Supercritical has invented a brand new type of electrolyzer. It's not like any others that exist already. We deliver useful high pressure hydrogen, and we deliver it at a level of efficiency not seen by anything anywhere else.
Supercritical technology is 25 to 35% better than other electrolyzer technologies on the market.
That means that this decade we're looking to deliver high pressure hydrogen for less than £1 per kilogram.
That's the tipping point for industry to switch to hydrogen. The likely early adopters of green hydrogen are going to be the ones that use hydrogen already today.
Hydrogen's not new. It's already heavily used. It's worth over £144 billion.
When it comes to our technology, we're perfectly suited for those sectors already. Those sectors all use high pressure hydrogen. Now we produce hydrogen at over 200 bar, ideal for their applications. We remove the need for a high cost, high duty compressor, which is difficult to run and difficult to maintain. What we're trying to do is offer a simple solution, but an elegant solution to be able to displace existing technology with minimal barriers to change. What makes this team special is the fact that everyone comes to work with purpose.
We're small, intellectual engineers, scientists who are trying to make a real difference for the planet. And that purpose-driven means that we're not just doing this and turning up and going home again. There is a passion that comes from all the people that are working on what we're doing.
It's so refreshing to be surrounded by people who care about the same things you do. We've got one sole purpose, and that one sole purpose is to develop this technology to help industry decarbonise. We're all in this together and we work together as a unit.
And we're looking for engineers, scientists, and problem solvers. People who like the unknown, the uncharted, who can come in the morning, feel like you've got to fasten your seatbelt because it's going to move fast.
Hi everyone, it's Luke here. Thank you for giving us the opportunity to talk about why our company is the company that will be the catalyst for sustainable life on Earth. In a net zero world, hydrogen is just quite simply unavoidable. It doesn't matter if you're considering its use for fuels, fertilizers or pollen products. The hydrogen molecule will play its role. Now we offer a route to the lowest cost of green hydrogen production, and we're ideally suited for 90% of the existing market due to our unique ability to deliver at pressure without the hydrogen compressors. Our process offers a 16% reduction in energy demand versus the leading incumbent technologies. But how? What is it that really makes us different? Firstly, our entire system sits at pressure. By pumping water to over 200 bar, instead of compressing that product hydrogen gas, we save 90% of the compression energy relative to incumbents like PEM and alkaline. But the pressure also means that we uniquely can go to temperatures up to 350 degrees C without evaporating the feedstock water into steam. This means we maximize energy density and we maximize conductivity, and it's this operating condition that we believe is ideal for green hydrogen production from water. It's our proprietary electrolyzer alone that can exploit this condition. Every other electrolyzer would fail. Membranes would dissolve, gaskets would blow, they are simply not designed for it. but supercritical has solved that problem. Our patented electrode architecture not only excels above all others, but in our complete redesign, we've systematically removed costly features of existing supply chains like iridium and rare earth metals. We've removed the first point of failure in any electrolyzer, the membrane, and in doing so we've removed the end-of-life and regulatory challenges of PFAS forever chemicals. And we've solved major system challenges like cooling and gas compression. It all lies in the brilliance of our innovation. Core to this is our cell, the efforts of the last 5 years. Hundreds of tests and thousands of hours online, this proprietary cell demonstrates leading electrical efficiencies at purity without a membrane. Now we're scaling that cell through what we describe as our block technology. In my hands here, I have an example of that block. It's made up of an anode side and a cathode side. This particular block houses 16 cells and incorporates an inlet manifold and 2 outlet gas manifolds. The blocks are then stacked together, connected, and then they're delivered in the form of a module, which offers our customers a neatly packaged plug-and-play solution to employ in their plant. Today, we are finessing the operation of that block and we're evaluating what we describe as short stacks. As we go into our pilot deployment phase, planned for 2027, we'll scale up these proven principles to deploy modules and larger arrays of those modules at customer sites. Excitingly, our pathway to that pilot is heating up. We signed 2 commercial contracts in 2025 as our customers build to a final investment decision, and we have 4 additional exciting opportunities in the pipeline. First mover demand is centered typically around Europe and markets enabled by fantastic renewables and supportive policy. Now, core to our go-to-market strategy is Europe, Morocco, Oman, and India. Right now, we are incredibly well positioned and hugely excited about what's to come. Having closed our Series A in December 2024, when we brought on Top Ventures as a valued shareholder, we've increased our team from 15 to 40. We've had our first patent family granted, 2 published, and we have 2 more patents in the works. Our customers are now paying us, showing us clear traction and momentum around our technology. We're on track to deliver TRL 6 in the first half of 2026, and we've just moved into our new London Tech Centre, a state-of-the-art facility enabling us to deliver through to pilot and beyond. We have a continued mission with Top Ventures and PTT Group, and we want to enable industry to think beyond fossil hydrogen. Thank you so much for your time.
Thank you so much, Mr. Luke Tan from Supercritical Solutions. Well, that was absolutely inspiring. Message to all those problem solvers out there and also here with us as well. ต้องบอกว่าเป็นเซสชั่นที่มีประโยชน์แล้วก็สปาร์กนะคะให้กับแรงบันดาลใจดีๆอย่างมากเลยนะคะขอบคุณคุณลุคทานรวมถึงดร.คุณวิวัฒน์ด้วยเช่นเดียวกันนะคะทุกท่านคะแล้วก็แน่นอนว่าสำหรับลำดับต่อไปเนี่ยเราก็จะมาดูกับอีกหนึ่งหัวข้อนั่นก็คือ sustainable chemical นะคะหรือว่าเคมีพันธุ์ยั่งยืนค่ะซึ่งเป็นหนึ่งในตัวขับเคลื่อนสำคัญนะคะของการลดคาร์บอนในอุตสาหกรรมปิโตรเคมีค่ะเพราะฉะนั้นสำหรับหัวข้อนี้นะคะก็จะนำเสนอโดยดร.ทัศวุฒิพจนาวราพันธ์ค่ะ CVC Director APAC จาก GC Ventures นะคะแล้วเดี๋ยวก็จะต่อด้วยสตาร์ทอัพตัวอย่างนะคะอย่าง Lacril Technologies โดย Mr. Justin Brown Chief Executive Officer นั่นเองค่ะและโอกาสนี้ขอเสียงปรบมือต้อนรับนะคะดร.ทัศวุฒิบนเวทีค่ะ
Thank you. Is my voice okay? Can you hear my voice from the back? Thank you. So thank you for having me today. Feel grateful. So my name is Taz. I'm the director of GC Ventures, which is the corporate venture capital arm of the PTT Global Chemicals. So for those who don't really understand about GC, who we are similar to Thai Oil. We are the downstream business flagship under umbrella of PTT, and we also listed in the Thai stock market today. So GCs, we are $20 billion companies. We have footprint in 28 countries around the world. We have manufacturing footprint in, as I mentioned, 28 countries, 90 manufacturing sites, up to 40 R&D research centers. And we have the capability to do the crude oil distillation up to 280,000 barrels per day, and can able to produce 1 million tons per annum of specialty chemicals, 12 million tons per annum of the petrochemical and commodity chemicals, plastics, and be able to produce up to 250,000 tons per annum of the bioplastic, and last but not least, up to 45,000 per annum of the recycled plastic as well. So for GC's venture, we were assembled around the early 2018 as the open innovation tools to help GC actually jump across the communities and become the specialty players by looking for more specialties and also more new technology and new business model from the open innovation ecosystem. So that's about GC's ventures. And then here, this is the picture of the team of the GC's ventures. As you can see from the top right is me, who also lead the activities in APAC region. And we have a team from the Boston led by Tony Sun, and he also here as well. So Tony Sun and his team lead the CVC activities in North America region. And we have Jerome, who actually sits in Netherlands for looking for the new technology, new innovators in the European continent. So as you can see for GC's venture, because we have a team in 3 major continents, that actually give us the strategic advantages to access the good innovators and good technology from around the world. So now, talk about the sustainable chemicals, why and what and why we need it, right? As you can see, chemicals is all around us, right? Around more than 20,000. Okay. Thank you. So around 20,000 products around the world today, they actually across many industries like coatings, pharmaceuticals, automotive, or even the cosmetics, they all need chemicals. And this is the reasons why chemical sector seems to be among the highest CO2 emitting sectors. Well, second to energy, of course. And this is actually set the stage for the corporate like us, because a lot of time we got asked that, okay, when you produce the chemicals today, and you seem to be one of the reasons that you emit the CO2 sectors, so that's why we actually focus in terms of try to find technology that actually help decarbonize the way we produce the chemicals today. And then also because of the demand from the customer, and also start to have come into play the policies, regulatories, all these levels together that actually set the stage for a shift or a need for the sustainable chemicals. And if you can look into the market forecast, it's actually forecast that within 10 years from now, the market size of the sustainable chemicals is going to grow up to $300 billion from around the world. And if you look into the right picture, you see that a lot of the activities actually carries by not only the corporate, but also startup as well. In particular, in the US market, you can see that there's a lot of activities by both entities, right? And this is something not unexpected, because US, they have a large abundance of the renewable or biomass resources. And they also have a strong support from the government for the bioeconomies. And then if you talk about the startup ecosystem, it's very strong and very robust system. All these three together actually, is unquestioned that why US actually leading on this one. But then if you look into the APAC, most of the activity in APAC actually carried by the corporate like us. And the startup is still not yet catching up, but again, there are some startups trying to solve the problem, but because the ecosystem here, majority in APAC is less compared to US, so that's why it's explain why this thing happened. So if you look into the innovation of the how to produce the sustainable chemicals, today there are 5 major main technologies that used to produce the sustainable chemicals. And if you look into the detail, thanks to the Lux research, we actually be able to find this picture from Lux research. So from Lux research, you can see that around 60% of the share of the innovation goes to the biotechnology, either biomass pyrolysis or biomass gasification, or even the biotechnology like fermentation or synthetic biology. All these three together capture majority of the innovation. And then the rest of the 20% go to the chemicals, and the remaining 20% go to the pretreatment unit. And as you can see, different technology, they have different pros and cons. But then in the end of the day, you have to look into the cost structure, right? For example, like the cost of the feedstock, the cost of the production, and together with the the cost structure, that's the whole reason, because this is the one that we know that is the valley of the death for production of the sustainable chemicals. And for GCs, we are looking for the technology that can be able to leverage the biomass or the feedstock that for GC we have the global footprint in terms of manufacturing. And we are looking for the technology that can be able to produce chemicals that have the cost parity with the fossil fuels, with little or no carbon premium. This is also very important because we see a lot of the good technology that it looks good in terms of the lab scale, it looks good on the paper, but once it comes to the commercialization, they are unable to make the product that match the cost parity with the fossil fuels production route. And last but not least, we are looking for technology that can produce the product that also capture the speed of the market. And this is also important because we don't want to find a technology that it looks good, but then by the time they can produce the product, there's no market for it. Or by the time they produce the product, it's a less ocean market, there's no opportunity for us anymore. So combine these three checkboxes together, we'll be able to get married with the larger technology actually. We met with the company 2 years ago, and we see that the company is be able to pass our checkbox here in terms of the technology we're looking for. And then what you're about to hear in a second is that you will see that how we actually work together with Larkhill, try to leverage the resources that GCs have by combine together the feedstock, the resources, and technology developed by Larkhill, how we can connect the dots and try to make it happen with that technology and with our help from the GC as the corporate and strategic investor. So without further ado, please join me, welcome Justin Brown, CEO of the Larkhill Technology, on stage to talk about Larkhill Technology and his company. Justin.
Perfect.
Good luck.
Thank you very much. Okay. Good afternoon. Always a tough time slot on a Friday afternoon. I'm the CEO of Larkhill Technologies, Justin Brown. Larkhill Technologies is a green chemical startup based in Chicago in the United States. We are currently 4 years old, and GC was our lead on our seed round. Today we'll talk about bioacrylic acid. So I always want to start with what changed. So what changed to enable me to come here? So there was an invention about 4 years ago at the University of Minnesota. My CTO is a leader in catalysis. He holds 120 patents, and both he and I are for Honeywell UOP. So if you had saw the SAF slide, UOP is usually at the top. And today we're talking about thermal chemistry, specifically catalysis. So what excites me is we always talk about green, but there's usually a green premium. And the problem is plastic circularity is really exciting. Coca-Cola wants all the bottles until you say it's going to be 20% more. So with this invention in the University of Minnesota, the yields of the lab scale catalyst were high enough to give us indicative price parity. So that is a huge development. All we had to do was take it 3 years, 900 iterations, and go from a lab scale catalyst all the way to a commercial scale catalyst and make sure that the process wrapped around it was successful. So when we talk about a commercial scale catalyst, we need crush strength as the catalyst gets loaded into the reactor. We have lifetime, regeneration, etc. But the key thing here was over the last 3 years, we've iterated that catalyst 900 times, and we've gone from lab scale to commercial scale. So the markets we're talking about today are large. Really, the 3 end markets are superabsorbent polymers. Think about diapers for the elderly or children. Then it's coatings and adhesives. Allnex would be a coating. And then those 3 markets are currently served via petroleum-based routes. And the petroleum-based route is a two-step oxidation reaction and has huge amounts of CO2 that are produced during that reaction. So the market is was 10 billion, has shifted to 12 billion. When we look at this, the CAGR of 4% isn't always as exciting, but because we're talking about a multi-billion-dollar base market, 4% on a $10 billion market is still quite large. We utilize a very detailed cash cost of production model, and then we have digital twins to enable us to understand the process. And this would equate at a 40,000 metric ton per annum plant to roughly 200 plants globally. So how does this look today? So if we look at what is this served with today, it's a petroleum-based route. It's an oxidation two-step of propylene, usually derived from naphtha. Those plants tend to run at a lower yield. That means that they're more complex because of the two-step process. The lower yield means that they have more byproducts. They're also large, expensive, and complicated. Our process hits parity at a much lower scale. How? We're driving yields at a much higher rate. The higher yields enable us to have less byproducts. Our production site is lower CapEx-wise, as well as site space, also because we're a single step versus a dual step process. And then you have all the benefits of lower greenhouse gases. We are feedstock agnostic, so we can take any bio-based sugars, cane, corn, beet, etc. So we take in lactic acid, do a thermochemical reaction through catalysis, and kick out bioacrylic acid. So this is the first time we've shown this video. This is done through our EPC. This shows our plant is fully designed through FEL1, front-end loading phase 1. This gives you the concept of the scale of the plant. So this is 100 meters by 120 meters. The key things are lactic acid comes in through the storage tank in yellow. We run it through our process. Again, it's a catalytic process through the small reactor in orange or red, and then we kick out bioacrylic acid. So one of the key things I always also want to understand is what are the right to play. So the right to play here is really 4 things. One is catalysis through our CTO, 120 patents, leading expert, 3 years running this process, and that creates a nice barrier to entry. Process engineering, because this is thermochemical, there is a lot of process engineering that wraps around that catalyst to make sure we get lifetime yield, etc. And because acrylic acid tends to polymerize, there's a lot of patents that can come out and a lot of process optimization. And then there's a large IP portfolio that goes around this, but then also the team. Our team, while only 8, has 200 patents residing within the team. So the history and the talent of the team is quite deep. And then lastly, because we're coming from established industry testing methodology, there's no question of, is this process capable? How can I ensure that the testing works? And are the results true? Then the next thing that comes up is, are we a one-hit wonder? Or do we have the ability to grow, and how do we grow? So we have already identified markets 2 and markets 3. Market 2 utilizes the same feedstock and the same catalyst. Market 3, a different feedstock with the same catalyst. So again, this shows that we're able to move into adjacent markets, apply our core competencies for our product market fit. And then this is on the left in the video, a twin screw extruder. So we make catalysts by hand by twin screw extruder. And then we also use toll manufacturers to make sure that as we scale, there's no surprises. On the bottom, this is our 4th plant, our first continuous plant. It started up in December. That plant will be creating samples in January, late January, and then the first sample is going to go to Allnex. And then really to wrap up here is, here's kind of how the portfolio would work together. So NatureWorks, as you know, produces lactic acid. They take in the United States corn as a feedstock or sugarcane in Thailand. So we are agnostic on the lactic acid feedstock. GC sits in a perfect place in the world. Asia is a huge demand center and has great breadth and depth from GC. So NatureWorks creates the lactic acid, corn in the US, cane in Thailand. Lacryl takes that as our feedstock. We convert the lactic acid to bioacrylic acid, and we do it at a 99.6% purity, so it's truly a molecule for molecule drop-in, and then we're able to drop that into Allnex's paints in Europe or any other end client's usage. And again, the key thing here is price parity is a game changer. And again, I just wanted to say thank you to the GC team for the invitation. 2026 is going to be an exciting year. We are raising our Series A later this month, and we've had our 4-year anniversary. Thank you.
Thank you very much. Big round of applause for Mr. Justin Brown from Lacryl Technology. Thank you for walking us through how the bio-based economy is being built sustainably, and also thank you very much Dr. Taz as well นะคะอย่างที่บอกไปทั้งเมื่อสักครู่นี้ถือเป็น game changer อย่างมากสำหรับอุตสาหกรรมปิโตรเคมีทีนี้ทุกท่านคะจะมากันที่อีกหนึ่งกลุ่มสุดท้ายปิดท้ายนะคะถือว่าเป็นอะไรที่น่าสนใจแล้วก็น่าจับตามองไม่แพ้กันกับ Nuclear Fusion พลังงานทางเลือกที่จำลองดวงอาทิตย์บนโลกนะคะซึ่งตรงนี้เนี่ยจะนำเสนอนะคะโดยคุณนรินทร์อภิสุทธิไมตรีค่ะ Senior Principal จาก Explore Ventures นะคะแล้วก็จะตามด้วยการพิชนะคะจากสตาร์ทอัพตัวอย่าง SAF Energy ซึ่งก็จะถูกนำเสนอโดย Mr. Peter Federici Head of Strategic Initiative ค่ะและตอนนี้นะคะขอเสียงปรบมือต้อนรับคุณนรินทร์บนเวทีค่ะขอเรียนเชิญค่ะ
สวัสดีค่ะดวงอาทิตย์คือแหล่งพลังงานที่มีไม่สิ้นสุดและเราก็ได้รับประโยชน์จากดวงอาทิตย์โดยการที่พยายามจะใช้แสงของมันในการผลิตไฟฟ้าอันนั้นคือสิ่งที่ทุกคนพอรู้กันอยู่แล้วแต่มันจะเป็นยังไงคะถ้าเราสามารถสร้างดวงอาทิตย์บนโลกนี้เลยและนั่นคือคอนเซปต์ของฟิวชั่นก่อนที่เราจะไปรู้ว่าสิ่งที่จะทำให้เกิดคอนดิชันอะไรบางอย่างที่จะสร้างพระอาทิตย์
But we need certain condition to be met in order to create or build a sun on Earth. We need to understand the what nuclear is different from fusion. Nuclear, or the old term nuclear, it's actually nuclear fission. You shoot some energy in, and then it chain reaction, explode and explode and explode more, and at some time to the point that highly likely you cannot control. Actually happens in the past as an accident in either Chernobyl and Fukushima. But fusion is different kind of nuclear. It's different. It's how we force the two atoms to clash with each other and release energy, and that is where the challenge is as well. What kind of condition that it will allow fusion to happen? 3 conditions. The first one is 10 times hotter than the sun, or 2, dense enough. Like you can see the picture where we're squeezing it in, or we also need it to operate 24/7 without stopping. Some countries claim that they can do some part of it, and some of the countries work together to create artificial sun almost successfully right now. One of those countries and companies between countries are SAF Energy. This is a company where Explore Venture has invested in. SAF Energy use a concept that is quite a bit different, where we create a lightning bolt in a cup, basically, where we can use 3 types of actions to happen here. The first one is Z-pin technology, where the atom can be bursted off and come back together. The second one is the shear flow or dense, make it dense enough. The first one is The first one is to create 10x hot, so that it's hot enough or hotter than the sun. And then dense enough is where we use the chair-fold stabilized technology. And the third one is we need a repetitive pulses to create 24/7 operations. If you want to know better about the SAP Energy, you have to listen to Peter from SAP Energy himself. Please welcome.
Hello, PTT Group, and thank you for having me at Sustainability Spark 2026. I'm honored to join you on behalf of ZAP Energy. My name is Peter Fedrizzi, and I lead strategic initiatives at ZAP. At ZAP Energy, we're building a seriously cheap, compact, and scalable fusion energy technology, one that we believe offers the shortest path to commercial viability and requires orders of magnitude less capital than traditional magnetic confinement or laser-driven approaches. So why is this important to the energy sector? Because fusion represents the ultimate clean energy source, carbon-free, fuel-abundant, dispatchable, and capable of delivering massive amounts of reliable power without the land footprint or intermittency challenges of renewables. If successfully commercialized, fusion has the potential to fundamentally reshape global energy systems and support industrial decarbonization, grid stability, and long-term energy security. With the support of our team, we'd like to give you a brief look at the breakthrough technology we're working on and the progress we've made to date. Please take a look.
To make fusion energy, you first need an extremely hot material called plasma. ZAP Energy's fusion cores generate a filament of Z-pinch plasma roughly 2 feet long. The plasma carries powerful electrical current, more than 10 times stronger than a bolt of lightning. Zooming in on the plasma, we see it's made of 2 isotopes of hydrogen called deuterium and tritium. When deuterium and tritium are compressed and heated to millions of degrees, their nuclei fuse. The reaction creates helium and a neutron. They carry massive amounts of energy that can be captured and harnessed. Just 1 ounce of fusion fuel carries as much stored energy as over 25 tons of coal.
There are a handful of innovations in human history that have had a profound impact on the human timeline. The invention of writing, the invention of language, the invention of farming. Fusion has the potential to have a similar impact.
I can't imagine a more compact device, and that's the real draw. It doesn't require magnetic field coils, no superconductivity, no external auxiliary heating.
I don't think anyone's working in fusion who's looking for an easy problem. In terms of having an energy source that's always on, that's reliable, it's hard to beat something like a fusion concept.
Everybody is all in on this project because people believe in the science, people believe in the concept, and people believe in the mission. So all these things make for an extremely exciting environment.
And that doesn't mean just the scientists who we work with. It means all of the engineers. It means all of the operations folks who actually make it happen. It's an incredibly galvanizing thing.
It's sort of like putting a lightning bolt in a jar and taming its instabilities. Technically, it's one of the most extreme sports you can play. There's high energy densities of every description, high electrical power energy densities, high thermal power energy densities.
Where ZAP is unique is that we're using one of the original ideas called the Z-pinch to do the confinement. But our secret sauce, as it were, our new technology is this concept of shear float stabilization.
We get to do things at scale, we get to have multiple machines operating at the same time, and these are all things that are really necessary to bring fusion onto the grid at a timescale that makes it relevant.
We've reached an inflection point in the technology sphere that allows us for a real shot on goal this time.
We know that our iteration speed is one of our superpowers, that we can design, build, and commission a new device within a year.
We want to develop a new energy source that's better than any one we've ever built. And Fusion has this capability, and in particular, ZAP's technology has that capability.
Existing approaches haven't delivered commercial fusion, and I saw an opportunity to identify a different type of technology and specifically where innovation could happen rapidly. And I think there's a very strong recognition that ZAP has a credible path to be the first commercial fusion company that puts electrons on the grid.
Thank you. I hope that gave you a clear picture of why we're so excited about what's ahead. ZAP Energy has now raised over $330 million from leading global investors, including Breakthrough Energy Ventures, Chevron, Shell, and Explore Ventures, PTT. This support has allowed us to move quickly through scientific milestones and build the foundation for our next major phase. Right now, our team is focused on scaling our Fusion Z-Pinch platform. We're transitioning from our current experimental devices to a larger next-generation system designed to demonstrate high fusion energy gain. Our long-term target remains ambitious but clear: to deliver the world the most compact, affordable, and deployable fusion power system, one that can be mass-produced into grids and industrial sites across the world, especially in high-growth regions like Asia. Thank you again to the PTT Group for the opportunity to be part of Sustainability Spark 2026.
Big round of applause, ladies and gentlemen. Thank you very much. That was what we've seen is, I would say, some of the most cutting-edge technology. Thank you very much once again to Mr. Peter and also คุณนรินทร์นะคะต้องขอบคุณอย่างมากเลยที่เราได้เห็นกันไปเมื่อสักครู่นี้ต้องบอกว่าขอบคุณทุกกลุ่มการลงทุนนะคะภายใต้กลุ่มปตทค่ะทุกท่านคะรวมถึงบริษัทสตาร์ทอัพนะคะเป็นอย่างสูงที่เล่าให้
Also I'd like to thank all the startups and venture capitals that are sitting here and from elsewhere. This is a real spark to everyone. This will be the topics, number one topics in the heart and mind of everyone here, because we are all here helping to move the world to a new direction. We have a QR code for you to scan.
Complete survey มีแบบสอบถามเล็กๆน้อยๆนะคะสำหรับการจัดงานในครั้งนี้ so please scan the QR code for a quick satisfaction survey และแน่นอนนะคะทุกท่านคะสำหรับกิจกรรมของเราในวันนี้ก็เดินทางมาถึงช่วงสุดท้ายแล้วนะคะตลอดเวลาที่ผ่านมาบนเวที Spark X Stage เนี่ยเราได้อัปเดตนะคะเทรนด์นวัตกรรมรวมถึงเทคโนโลยีแห่งอนาคตที่กำลังเปลี่ยนนะคะแนวคิดเรื่องของความยั่งยืนเนี่ยให้เป็นพลังในการขับเคลื่อนเศรษฐกิจและสังคมอย่างแท้จริงนะคะเพราะแน่นอนค่ะว่าสำหรับคำว่าความยั่งยืนแล้วเนี่ยไม่ใช่แค่หน้าที่ของเราคนใดคนหนึ่งเท่านั้นแต่มันคือหน้าที่ของเราทุกคนนั่นเองนะคะ Well, and that is how we wrap up the Spark X stage, ladies and gentlemen. Do look forward to the next multiple series of success stories on this sustainable pathway. I'm Nun Nachanan. Until we meet again. สวัสดีค่ะ